Good morning, everybody, and welcome to another exciting UKDEA event. This morning we're hosting it in collaboration with BEIS, and this is the first joint national conference which is focusing on utilising waste heat in district heating networks. So I suppose a question should be, or could be, why now? Why are we talking about waste heat now? Well, fortunately, I woke up this morning and the BBC news feed happened to give me a really good hook. And that hook came from the International Energy Agency's press release that there should be a global ban on all gas boilers by 2025 to reach net zero. And picking up on that hook as well, the diagram on the right clearly shows the enormous impact that heat has on carbon emissions, and hence the importance of decarbonising heat in order to reach net zero. So very good reasons for why now. So before we go into the conference itself, I'd just like to tell you a little bit about the UKDEA to explain who we are if you haven't come across us before. So we're a non-trade, not-for-profit organisation, and we offer guidance and support to everybody in the sector who wants to join us. We've got scheme developers, owners and partners at the core, at the full members, and then around the side we've got the extremely important associate members, the equipment suppliers, installers, consultants, education, services and providers, etc., etc. And our remit, our reason for being, is to offer guidance and support and raise awareness. And we started from humble beginnings in 2010, over 10 years ago, with 6 founder members. We're now approaching 130 members and we're growing rapidly. I was having a chat with one of the speakers yesterday and explaining that this last month we've seen 5 new members join us, and these aren't people who are going out and aggressively selling the concept of district energy too. These are people who are entering the sector and approached us and asked to join. So that's a really exciting development, and it just shows that the time for district energy is now. And all the major district energy schemes in the UK are represented by the UKDEA. So just finally for me, as an introduction, to explain a bit more about what you do and what you can gain if you're a member of the association. So we're a respected voice for raising your concerns to government. As you can see, this is a joint event with BEIS. We work in very close collaboration with them. We publish every month a 50-page journal. It's pretty much everything going on in the world of district energy in the UK. That's keep you up to date and informed. You don't have to check the news feeds. You don't have to surf the web. We do that for you. We bring the news to your inbox. We also have an annual conference and an AGM, as well as many networking events, such as the one we've got today. Hopefully soon we'll be able to go to live events, but it's today we're still in the virtual world. So we've got a feature-packed website and library. We've got the training register with over 50 different training courses from 20 different members. We offer help, advice and support, and we've got a network of members working together to assist each other. So it's a really exciting and interesting association to be involved with. So that's really enough for me as an introduction to the day, or the morning, I should say. And I'd like to ask John Saunders to come onto the stage. And John is the project director for Heat Networks. And John will be presenting some more about BEIS, the waste heat, and its importance to the sector. So thank you very much indeed. I'll hand you over to John and say goodbye for a few minutes.
Thanks, Simon. Yeah, good morning and welcome, everyone. Thanks for joining us today. I guess I'm going to really just try and frame all the really exciting stuff we're going to hear later on in the session. As Simon said, I'm project director for Heat Networks and BEIS, and have broad responsibility for development, delivery, support, and regulation of heat networks across England and some of Wales. So really interesting that Simon started with the article on the BBC. Actually, over the last several months, there's been more commentary in the most unusual places on climate change and our need to do more sooner than I've ever seen in the now 14 years that I've been in sustainability. In papers that maybe wouldn't have expected to see this in the past, Daily Mail, The Express, The Sun, championing for change. So I think broadly there's wider recognition that we need to do more. Actually, you might well have seen that just a few weeks ago the government committed to a 78% reduction in carbon emissions by 2035. To put that into context, up until a few months ago, the figure was in the 60s. So, government is also recognising that we need to do, much more sooner in order to keep us on the pathway to net zero by 2050 and avoid the worst effects of climate change. And so that really requires us to think more about where our carbon emissions come from. And broadly, we've made great progress on decarbonising the power grid. You'll have seen the quicker than envisaged rollout of large-scale solar PV, of wind, and the UK success story, especially on offshore wind, along with a commitment for a further 40 gigawatts of it over the coming years. But actually, we need to do more. We need to do more on transport, and we need to do much more on heat, and specifically on heat in buildings. And the kind of the graphic in the top right of the slide just gives you a breakdown of of where the emissions come from. And heat historically has been a bit of a kind of forgotten part of the story. I think a lot of people, when they're talking about energy, meant electricity. But as we know, a third of carbon emissions come from heating, and so failure to address that means that we'll fail to meet the important targets that we have. We've been talking about decarbonisation of heat for a number of years, and broadly we talk about these various pathways to decarbonisation, and these will be familiar to you by now. Broadly, there's an electrification pathway, heat pumps, electric boilers, etc. There's some kind of low carbon gas, hydrogen pathway, and of course there's sort of heat networks. I think historically heat networks have been seen as a kind of a third pathway, but I think that's unfair. I think it's a pathway that facilitates both of the others, with an important addition that we're going to come on to today, which is that heat networks can, of course, unlock the large-scale, low-carbon sources of waste heat that the other pathways can't on their own. So, where are we today? Well, heat networks, as you'll know, are right the way across the country. There's tens of thousands of them, but actually they're still only providing around 3%, and I'm doing a bit of a friendly rounding up here, around 3% of UK heat demand. And the latest Committee on Climate Change report suggests that actually, we could be delivering up to 20% of heat by 2050 to help us deliver net zero. So, huge amounts of effort and work to date, but still a long way to go. I mentioned, one of the reasons that, government really likes heat networks, and that's their ability to unlock these large-scale, low-carbon sources of heat. The kind of stuff that you just wouldn't do on a building level scale, whether that's energy from waste, mine water heat. We've recently seen, heat coming from the Tube in London, large-scale water source, industrial process heat. Many of the things that we're going to hear, later in today's session. Probably not going to do that on a building scale. You definitely can do that from a heat network perspective. I mentioned that actually, a heat network can respond to any future pathway. So, if hydrogen is proven, then actually heat networks are well placed to make that as efficient and safe a process as possible. If we end up going electrification route, there's definitely benefits from that side. And the way that the heat network can interact with this energy system in a really efficient way, reducing overall demand is a real positive for us. And so, we've been putting in support for several years, excuse me, and we think there's a fantastic investment opportunity for heat networks right the way across the UK. It's going to require an awful lot more effort to keep us on track on this annual growth rate that we need, and an awful lot of investment from a wide variety of actors. So just thinking about, why waste heat is important. There's some reasons that I've kind of jotted down here, but I guess from a government perspective, the main thing is that we need to find sources of heat that are as low carbon as possible, that are kind of compliant in a net zero world. And in doing so, it keeps heat networks relevant. It keeps heat networks acting as that important contributor to get us to net zero. So yes, absolutely, waste heat is going to save carbon and help us maintain the strategic rationale for heat networks. I think it's got a really interesting role as well to diversify those local supply options, whether that's diversification in a heat network setting because you've managed to source a wide variety of heat from different places, or actually whether that's diversifying from a decarbonisation of heat pathways, so reducing the need for electricity or hydrogen because you've managed to secure some of that heat from other places. If we look at this from a wider resource perspective, making other processes more efficient has got to be a good thing. Take the example of energy from waste. The way that they jump up in the levels of efficiency is by finding a useful home for that heat. So heat networks have then enabled another part of industry to be more efficient. Definitely see a role for waste heat in reducing overall energy system costs, and I'm certain this is going to be a topic for conversation as we go through the day. By virtue of making sure that we're able to get say heat pumps working as efficiently as possible, finding those sources of heat that optimize the way that heat pumps are used and therefore reducing the overall demand on local grids, and this kind of question around building level or network level solutions. So on the left of the screen, this is hopefully I've got the right places come from, but this is an old study that Bureau Happold did for GLA, looking at some of the waste heat opportunities. And I always really like this as a way to frame the kind of exciting range of stuff that we could try and access with a heat network. And then on the right, this kind of tells our story, I think, of where heat networks and government support and the sort of direction of travel. We've got an existing heat network base, which is predominantly gas-fired, whether that's CHP or gas boilers. Actually, through our main flagship program, the Heat Network Investment Project, this is quite small, so maybe I'll just describe it. The dark blue in the top one has got a bit smaller in the kind of the lighter blue in the middle one. And then as we transition to the Green Heat Network Fund, our new capital scheme, again, we're looking to remove gas almost entirely from the projects that we support, other than the kind of the natural peaking and top up. And this is going to be the direction of travel. Simon talked at the outset about all the news about the move away from gas and how it's starting to gain public and political acceptance, that this is something that's going to be a really important next transformative stage. So I guess I was just going to close on what are we doing about it if we care so much, and I'll just do a kind of whistle stop tour. I mentioned the Heat Network Investment Project. That's in its final year and has been our 320 million capital scheme. We've got another 2 funding rounds remaining, and that's definitely kick-started the transition from high carbon to low carbon. The Green Heat Networks Fund, due to launch next year, is our new capital scheme, and it really looks to kind of build the foundations for a low carbon market in heat networks through the rest of the decade, supporting connection to energy from waste, large scale heat pumps, etc. We've got our new heat networks efficiency scheme, essentially looking to optimize some of these networks. That has benefits on its own, but actually some of these optimizations might also enable connection to waste heat, bringing down the temperatures. And we've got a skills program planned, looking to make sure that we've got a marketplace capable of meeting the needs of this growth that we need to see, throughout the 2020s. And then, of course, we've got a kind of a regulatory package. So our heat networks market framework, which includes our planned regulation for the sector, and also our heat network zoning policy, where we're looking at ensuring that we're able to designate certain areas as heat network zones, be clear on the buildings that we expect to connect in those zones, and then consider the appropriate levels of mandation to ensure that heat networks we think are economic and technically viable then are built out and start meeting the needs of the sector. And then on the right, there's a whole kind of range of stuff that we've done basically to try and understand the role of waste heat in in these heat networks and the art of the possible, and really challenge ourselves to think about what heat networks look like over the next 10, 20, 30 years. And again, we're going to hear more on that, I think, on Simon's presentation around the various ages of heat networks. So that was it from me. I'm going to stick around for a bit, and if there are any questions, happy to respond to them in the chat. Hopefully that kind of sets the scene for the rest of the day and just all the excellent speakers that we've got planned.
Lovely. Thanks very much indeed, John. Much appreciated. I'm sorry to say this, John, but you've already got in the chat the question that most probably is burning on lots of people's lips: the role for gas-fired CHP moving forward. So keep your thoughts on that one, and if you can come back in the Q&A session and respond, that would be great. So thanks very much indeed. So if I could now invite Hen to come onto the stage. Hen Cooke from BEIS, who's a heat network specialist, and Hen will be opening a window onto the research that BEIS have been doing looking at waste heat and the National Comprehensive Assessment. So over to Hen. Thank you very much.
Great. Thanks very much, Simon. Good morning, everyone. Really, really excited to be here. It's a subject that's very close to my heart. I used to work in waste to energy electricity sector, so it's great to be working with it in the heat sector. For me, it's all about increasing resource efficiency, which seems at many levels to be a sort of no-brainer. So yes, as Simon said, I'm here to give a bit of an update on some of the work we've been doing to better understand waste heat opportunities at a national level. So coming at it kind of from the opposite end of the ground up work that you're going to hear about later in some of the case studies. And I'm also going to outline how we've been using this data to explore potential for utilising these sources to supply heat networks across the UK in what we call the National Comprehensive Assessment, the NCA. So the specific piece of research I'm going to go over here is a piece of work we commissioned last year from Arup and the London South Bank University. As I imagine many of you will be aware, we've been engaging with the energy from waste sector for some time around heat recovery, both at a project and a national level. So this piece of work was actually an attempt to broaden our analysis to other sectors. So just to be clear, the following slides do not include energy from waste. So the aim of the study was to identify where there's most potential for waste heat recovery and where we should be engaging at sector level. There's a definite recognition, which again, I'm sure will come through the talks that follow, that each sector has its own particular characteristics, both in terms of technical opportunities and challenges, and also in the sort of the ecosystem of commercial and regulatory arrangements around them. Just one other point to note, so again, in terms of scope, that this study was done for England, Wales and Northern Ireland, as Scotland had already commissioned their own waste heat study. So we started by asking Arup and LSBU to help us scope out which sectors to cover. So they looked at existing studies, so what we didn't need to repeat, as it were, the scale of opportunity, data availability, and so on, data that being a critical aspect in this kind of work, the heat potential and so on. And we came up with a list, which we grouped here into 4 categories to sort of just really, they're just to help organize the data really. 2 specific ones, which are electricity substations and wastewater, and 2 more kind of catch-all ones, industrial heat recovery with things like cement works, chemicals, paper and pulp and so on, and then what we've called commercial, so cold stores, data centres, supermarkets and so on. So once we decide on the sectors, we then, or ARP and LSBU, then drill down into them to get an understanding of the potential in terms of the numbers and locations of sites, the scale in terawatt hours of heat, how that's distributed across the different asset types within that sector and so on, before undertaking the really detailed analysis on each sector. So this technical analysis was involved quite a challenging task of coming up with what I sort of inverted commas call a typical configuration for heat recovery plant for each sector. I'm not going to go into this in detail as I'm not a technical person, and Joel's going to be covering it a bit later, so please save all your questions for him. I'm sure he'll have all the answers. But essentially, as said, it was pretty challenging to do this at a generic level when in reality, every plant will be different. But they managed to achieve a really good balance of detail and generality, which worked well to serve our purpose. So the important thing was to identify and size all the bits of kit needed to recover the heat from the various different processes so that we could price this up and develop a costing metric that would enable comparison between the different sectors. So, sorry, this isn't a great slide, rather a lot of information on there, but this is it's effectively what we got from the search was a great big database and some maps. So this is an extract from the database. Lots of information here, but I guess the main things for note for now are that these sectors alone were identified about 10,000 sites across the country, excluding Scotland. And between them, they're releasing some 60 terawatt hours of heat, just way off into the sky. For context, the estimated heat demand across the whole of the UK is of the order of about 470 terawatt hours. So that puts it in perspective. The sources in the different sectors generate heat in different ways, and you extract it in different ways, and it's at various different temperatures. I've ranked it here in terms of temperatures. We've got the high temperature industrial process at the top, like cement and iron and steel, the low temperature commercial utility process, such as cold stores, water treatment works, and so on at the bottom. The next slide is one that's probably of particular interest, which is where we actually came up with the costing. So this is what we calculated here was what we call the levelized cost. I'm sure many of you are familiar with the concept of a levelized cost, where you bring together both capital and operational costs over a period of time and discount it to today so that you can compare different technologies which have different life cycles on an equal basis. I think the really important thing to note here is that this is what we call the levelized cost of capture. So it does not include any costs of upgrading the heat to the required temperature. So as I said, some of these, the heat availability will be at sort of 10, 15 degrees, but your heat network might need it at 70, 80 degrees. So there's some heat pump energy required to upgrade some of the lower temperature types of heat. Those costs are not included here, just to be absolutely clear. I think Simon's going to talk about different generations of heat network next. So the temperature of the network will clearly influence the cost of heat required. So how have we been using this data? Well, as I said, as well as helping us to get a feel of the scale of the potential for the different sectors, we've also used it as a key input in a national geospatial model. So we've combined it with building level demand data and to try and work out where heat networks could be a viable proposition. So the model uses an algorithm, which pulls together demand density, proximity of demand to supply, and the cost of supply. I'm afraid the assessment hasn't yet been published, so I can't share data with you just yet, but I can show you some of the maps that have been generated. So this first one is of heat demand. In many ways, it's not particularly surprising. You see the bright spots where there are big cities. As said, this is based on pretty granular building level data from Ordnance Survey combined with benchmarks of heat demand for different building types. And we had tried to do some kind of calibration with gas demand where that was available. So, and the next slide, so this is showing the heat sources. So this includes the heat sources I've just been talking about, but it also includes all the other ones like energy from waste, the thermal power stations, CHP and so on. We had to map this at LSOA level rather than as point sources due to data permissions issues. So as I said, that's been an underlying challenge with this piece of work is getting access to the data, and it's meant that we cannot yet publish the detailed data underpinning some of this because of permissions issues. So it's worth noting that the total waste heat mapped was of the order of 370 terawatt hours across the whole of the UK. As I said, while demand is about 470. I thought it was quite useful or interesting to show the two maps together side by side. So here, the demand on the left and supply on the right, you can immediately see that the high levels of demand and high levels of supply are distributed slightly differently, which in many ways is no surprise. They're doing different things. But there are overlaps, and clearly this is where our interest lies and where we think that the prize is. And the final map is where the model suggests that heat networks could have most potential. So this, as I say, matches supply and demand, where the supply is the point sources we've been talking about, but it also allows for heat to be supplied by what we call location agnostic sources. So where there's, the model will say, okay, there's enough heat demand in this area to warrant building an energy center with a large air source heat pump or ground source or whatever. So the distribution follows pretty much the demand distribution. So very quickly in summary, I think I'm coming to the end here. Basically, there's a lot of waste heat out there being generated across the UK. It's a resource that we really want to capture and make use of. Different sectors have different characteristics, which we'll hear about later, in terms of the temperature of the heat, the technology required to capture it, where they are. And as a consequence, the cost of recovering heat from the different sectors is different. As I said, the geographic spread of demand and supply does not totally align, but there are areas where the significant areas overlap, and those where we need to target in the work going forward. So that's it. Thank you very much.
Thank you very much indeed, Hen, and really interesting. You've got a number of questions in the question session at the side. Refrain from answering them if you don't mind, because you can come back on the stage at the end of my presentation and answer them. But a lot of it is about the data set, when's the data can be available. We've got lots of hungry delegates out there who want to start mining this and hopefully developing schemes themselves. So thank you very much indeed. So I'll invite you to leave the stage. And we'll pass over to myself now, and I'll do a little presentation at really explaining why we think waste heat is so important, a bit of a history lesson really, and I think hopefully you'll find this quite intriguing. So this is about utilising waste heat in what we in the UKDEA are calling the third age of district heating. So if you've only recently entered this particular sector, you may not be aware that this has been around for an awfully long time. District heating networks, whilst they still might only be 2 or 3% of heat in the UK, they've been around for a while. There's an interesting document on the right-hand side that was published in November 1971, so 50 years ago, looking at district heating networks and the government's support for them. And what you may not be aware of, there was an awful lot of heat networks installed in the 1960s and 70s. They were largely there to sell coal, oil, fuels, central emission abatement, things like PDHU, removing central emissions, and the concept about just a central boiler, more efficient than a poorly designed and maintained heating plant in each individual building. So this is the 1960s, the 1970s, and many heat networks were promoted just on that efficiency benefit. But for those of us who are around in the sort of the 1980s, you will recall that lots of those networks weren't efficient, they failed, they suffered with problems. And therefore, in the late 1970s and early 1980s, the buzzword was decentralisation. I personally graduated in 1987 and joined W.S. Atkins for a couple of years, and indeed worked on some decentralisation projects, ripping out district heating networks. and putting in these super new high efficiency boilers in individual buildings because the heat networks at that time were so poor. However, we turned the corner. We realised, learning from our fellows in Europe, that you could build efficient heat networks, modern piping systems, etc., etc. And in the late 1980s, you started to see a new breed of heat networks coming about. Energy from waste in Nottingham and Sheffield, big schemes, big citywide schemes, geothermal in Southampton, etc. So that brought to the close what I would call the first age of district heating. So let's move on to what I would call the second age of district heating, a fairly stable period in my view, from roughly speaking, let's call it 1990 to 2020. So at the start of the second age, we've got a good understanding you can build heat networks, that heat networks are efficient, and a well-designed primary heat network should have heat losses of less than 10%, should ideally be 5 to 7. We're not talking there about secondary network losses in buildings. That's the subject of a whole other event we'll be organising, but ideally should be very low. And there was really, as John showed on his pie charts earlier very helpfully, a very widespread use of gas-fired CHP, driven by spark spread, driven by viability, essentially an engine generator recovering waste heat. And there were many large-scale schemes delivered on that basis: Birmingham, Leicester, Olympic Park, etc., many, many others. So that was a long-term period. We're talking about 30 years. But by the end of that second age, by the time we reach 2020, we're all recognising the grid is decarbonising. As John mentioned, there has been a focus on reducing the electricity, the content of the grid, and not so much on reducing the content of the carbon content of heat. And although CHP remains viable, its carbon benefit is perceived to have been reduced. And already in the chat, we've got the expected question about the part that CHP has to play moving forward. As you'll have seen from John's pie charts, which he helpfully put on the screen, the heat network investment project had a significant component of gas CHP in it. The Green Heat Network Fund, its replacement, is expected to have very little to no contribution from gas CHP. So how do we transition now? We'll talk more about that in a moment. And the CHP benefit arises from fully heat recovery. That displaces central-only power generation, but as central power generation becomes more efficient, increasing proportion of wind, solar, etc., the benefits reduce. So you're displacing electricity which has a lower carbon content. But we do believe that if you analyse CHP on marginal factors, and as John said in response to his chat, I think industry and ourselves are in quite a different place to government, that the CHP still makes sense, but not on our average carbon factors. Are we clear on central government's position? I think, as John's quite rightly said in the chat, there's a bit of a dispute going on. There's clearly some messages from government saying that they support CHP as a transition technology. They will support industry to move forward. There won't be a cliff edge, and we're hoping to work with the government to find a satisfactory solution to that. Although, as John said, the recent consultation, SAP 10.2 updates for heat networks, seem to put the death knell in the coffin of CHP for new build. We're hopeful that we will manage to navigate through that process and keep us back on the track where CHP becomes a transition technology where appropriate and where we can demonstrate carbon savings can be made. But let's face it, gas-fired CHP is a technology that is in transition out, and we need to focus on the future. It's confusing. So what happens next? What do we do in this third age? So, as I said, we believe, personally, the UKDEA and our other associations in the sector, that gas-fired CHP has some role to play as a transition technology because it offers a viable solution to create heat networks. But the landscape is changing, and we personally believe in the UKDEA that waste heat is a very significant source of energy that needs to be explored and developed in this third age. I think the problem is, and the way I describe it to people, is there is no single out-the-box solution. This isn't about finding a plant room with sufficient space, plugging your CHP unit into the yellow gas pipe, and just simply cracking on with the project. Waste heat is a very complicated beast, as I'll come on to explain in a minute. But I think what's really important to say is you're not alone with wrestling with this issue. We are all collectively wrestling with it. And if we have a conversation together, we will find the right outcomes. It's where people try to do things in isolation that it doesn't work. So we are jointly on a journey to enter the third age of district heating and make that a success. So I think the first question's got to be, in my mind, and John touched on this, is why are we even using heat networks? Why don't we all just go to individual building solutions, stop disrupting people, stop digging up streets, stop causing problems? Why do we need to put in heat networks? Well, to me, networks make sense if they deliver a material decarbonisation benefit that cannot be achieved at building level. And this is exactly what John was talking about in his presentation. So either A, they're using heat sources that you can't access at a single building level, energy from waste, industrial waste heat from data centres. You're not going to build a heat connection to a data centre, very unlikely to do so for one building, again from energy from waste. You'll build a network because that's the only way you can make these viable. And or where a heat network can bring improvements in viability, efficiencies, or financial economies of scale. So you can get an improved heat pump COP because you're utilising a source which is a higher temperature than, for example, an air source heat pump locally in the building. It also removes the need for widespread grid reinforcement, and it combines heat loads at different times of the day, week, dwellings, commercial, increases that utilisation of central plant. Therefore, we believe firmly, and this isn't preaching district energy for the sake of preaching district energy, we genuinely believe, as does the government, that heat networks have a major role to play in decarbonising heat in the UK in the appropriate place. But it's complicated. And this is a bit of a busy slide, so I'll take you through it slowly, because I think it's important for people to understand, discuss, agree, disagree, etc., etc. So there's two groups of boxes on here. So there's two sources. The top box looks at higher temperature waste heat. So in my mind, there's higher temperature waste heat. You don't need to introduce a heat pump into the mix in order to be able to use it. So that's energy from waste, high temperature industrial waste heat, those things that can be fed directly into a heat network. But the problem with those is the locations are limited. They're not everywhere in the country. They are being developed in specific areas, and we'll hear about some examples from that this morning. Indeed, one of the next speakers, Gareth from Cardiff, will be talking about the heat network that Cardiff City Council are creating from the energy from waste plant in Cardiff, but the locations are limited. And then the second group is those lower temperature sources that require some form of electricity to turn them into a source that can be used, unless clearly you're developing an ambient loop network and putting individual heat pumps in each building. And there's a plethora of different sources, and we'll hear more about those today. But I think, again, it's about having this joined up conversation, including BEIS, including all the stakeholders. The problem is there is an awful lot of waste heat out there, and many of these points apply equally to the bottom box as they do to the top box. There's a lack of incentive. There are no drivers which encourage those waste heat owners to put their heat into heat networks. It's got a very low value. It's most probably something that sits at the end of their process that they've got no interest in. They just waste. And even if you buy it, the value that you attribute it, buying it off them as waste heat, is so low, it doesn't have a big impact on their P&L. So why should they? And also, an energy from waste plant will most probably want to operate in electricity generating mode. That's one of the issues that we often come across. Location. The source of the consumers are quite often, particularly things like energy from waste and most probably large-scale industry, not well located, and they will require lengthy interconnectors. But that's one of the things that I know that BEIS are hoping to fix with the Green Heat Network Fund. Waste heat versus electricity, I've mentioned. Waste heat availability. The problem is, as a heat supplier, you have to guarantee heat to your heat consumer. You need to know that can come. You need to know that across the year and across the long-term period it can come. So you need to put in place backup and top-up borders, because typically these sources will have an availability. But you also need to think about what happens if that factory moves, if that energy from waste plant closes down. So you're sitting in the middle as a heat shipper, not a heat generator. It's a very different commercial offering and solution, and it comes with different risks. And you need to put in the backup boilers for the reduced availability or the lack of 100% availability from your heat source. So then if you go to the lower box, you've got the cost of accessing the resource in terms of the heat recovery equipment that you need to put in. You've also clearly got the viability post non-domestic RHI when competing against a gas-fired boiler. So typically heat in the UK is sold. Many energy services companies are selling that against a gas boiler counterfactual. So the whole life cycle cost of heat from a gas-fired boiler. But if we're going to enter this net zero world, we need to move away from that. We're not, as my second slide said in my first presentation, gas boilers will go. So it's not fair to compare us against the cost for a gas-fired boiler. For some, there's a real distance from the network, and the greater the difference between the source and the use temperature will naturally produce a lower COP. I mean, if we've got heat at, let's say, 40 and your network's running at 70, the COP of the heat pump will be much greater. If your heat source is only 5 degrees C and you're still trying to get to 70, clearly the COP is much lower, and that dramatically impacts the viability of the scheme. So these are the types of issues we need to work on together and resolve to find viability. So are heat networks viable in the third age? Well, I think, and hopefully this isn't too contentious, but I think it's important to be contentious at some points to crystallise the discussion. I think that high temperature waste heat, with commercials that works, and once you can resolve the availability, etc., those nuggety commercial issues that somebody wants to contract with you, say it's less than a penny and a half, it's possible. I'm not saying it works every time, but it's possible. But low temperature waste heat, where you have to introduce some form of electrification, you have to introduce some kind of heat upgrade with no RHI, and where the heat charges are set against a gas-fired boiler, because we have not got to the place yet in the market where we've socialised some kind of future home standard counterfactual, where people in dwellings understand the cost of decarbonising heat and the price that they will have to pay. But even with a significant capital grant, I don't think it's viable. So what's the solutions? Well, we believe in the UKDEA there's a need for a low carbon heat network incentive. It's similar, but it's absolutely not the same as the RHI. It's absolutely clear in our mind that the door has firmly closed to RHI. And we need to think creatively and collectively about how we ask the government for fiscal support to help access these sources of waste heat in a viable manner to bridge the gap until we've got a socialised understanding that comparing the cost of heat from heat networks to a gas boiler counterfactual is not correct, and what heat charges need to be to reflect a zero carbon solution. So we're currently developing policy proposals to address these issues. We're in dialogue with BEIS about these issues. If you want to join our conversation, please get in touch. There's my details there. Whether you want to get in touch just to chat, whether you want to get in touch as the 5 organisations have done this month to join us, please do get in touch. So that's it from me, really setting the scene on waste heat in the third age. And I'd like to invite Hen and John to come back and join me on the stage to talk about some of the issues that have been raised in the questions. So I can see John joining me. Thanks. Hen, are you okay to join? So, yep. Hello, John. Hello, Hen. So you've been typing away to lots of question responses. So I don't want to be draconian and point out particular ones, but John, can I sort of pick on you first and maybe just talk a bit more maybe about some of the responses that you've written in the chat? I think particularly about hopefully gas-fired CHP. I see you've responded to the Green Heat Network Fund, but if you could pick on a few of the questions and talk about those, John, if you don't mind.
Yeah, happy to. Unfortunately, I've got someone cutting down a tree in the neighbouring property, so apologies for background noise. Yeah, I mean, on gas CHP, I guess, yeah, there's, on the one hand, it's difficult to say too much more because the consultation has just closed, but I don't think we're expecting it to say anything that we haven't already heard directly from industry. In the last several months that we've been working closely. Which is our analysis suggests that the tipping point for gas CHP and the carbon benefits associated with it has passed, and that it is now becoming clearly a negative contributor to carbon and climate change. That is built around a whole host of assumptions around carbon content of the grid and the stuff that it replaces when it runs, almost entirely to do with the power side, of gas CHP, and so we've been going through sort of detailed, I guess, analysis, with industry, setting out, what's driving the figures, and it's fair to say that, I think we've got some agreement on some aspects, but we're in a very different place, on some key areas, which is effectively drive the difference between gas CHP being still okay or not okay, and so we've got to work through that over the coming weeks. The challenge we've got is that we understand the economics of heat networks and gas CHP and the value that the power brings. So clearly there's a challenge if you just take that out of the picture immediately around the economics of some schemes. We also like to base policy decisions on things that translate from our analysis to what's actually going on in practice, and so making sure that there's a clear connection between the two, so that we don't get these kind of perverse outcomes is going to be really important. So as I say, more work to be done. We want to provide certainty as soon as possible, but having to go through this next kind of stage of responses that we've received to inform the next stage of work.
Thanks very much, John. That's really helpful. John, I'll turn to Hen now, but can I just ask you to look at the couple of questions asked by John O'Shea in the chat just now about underwriting risks and also about waste heat templates for MOU, and then I'll come back to you. So Hen, lots of questions in the chat for you, really about the data source, availability, timings, and there's also some other questions in there about whether heat storage was looked at. So could you respond, I think, firstly on the data, what can be released and when, Hen?
Yeah, I mean, I have to say it's been a big learning curve for us all on the data access issues. So, and I've read other studies done and elsewhere in Europe where it's a constant problem with waste heat is actually getting access to data and sharing it for commerciality reasons. So I think on the supply side, we just got to sit back and think about how we deal with this. As I say, we've had to disclose, we've had to show the waste heat on an area basis, not on point sources. The extent to which we can share individual data, perhaps if people come to us with specific questions, we might be able to share that way. But I don't think we can do a blanket publication of the database currently. On the demand side, I mean, a lot of the information is publicly available, it's Ordnance Survey data, which we've, as I say, we've just linked with benchmarks. I think we're sort of in an interim stage as to what we do with this map, this model. We're only just completing it now. It's a potentially really fantastic resource, but I think I'm afraid we're going to have to say watch this space for another month or so, and we're looking to publish the NCA, which was actually a requirement under the EU Energy Efficiency Directive and currently now under our own legislation to publish every 5 years. So we're looking to publish that in the next month or two. But as I say, the underlying data sets, I'm afraid we have to be, we need to work through how we can best share that for industry.
Okay, thanks very much, Hen. I'll turn back to John. Hopefully he's had time to have a think. Hen, there's a couple of questions in the chat about heat storage, etc. in networks.
Yes, I might leave that to John.
If you feel but if there's anything you can say about, I suppose, really a bit more about how particularly electricity was considered in the study. I'll come back to you in a minute if you don't mind. Yeah. John Saunders, do you mind responding to John O'Shea's two questions? So one about government underwriting risks of those future waste heat sources, and also about sort of standard forms for how people contract for these waste heat sources.
Yeah, thanks. So, John, we produced a kind of heads of terms contract set, some time ago, and they got then translated into kind of more fully formed contracts through something called the Sales Operations and Maintenance Set, delivered as part of HNIP, and these are all widely available. there isn't one that's specifically headed, waste heat, contract, but there is a bulk heat supply contract that's available, which I think would start to serve the purpose. I think kind of linking, that question to your other question, I don't know that it would go far enough to consider, what happens if this waste heat source goes out of business, which is, a different kind of consideration. And in terms of the kind of underwriting, I think it's a really interesting, question. And we've certainly been asked to consider underwriting drilling risk on deep geothermal, for example, and the risk that you don't hit hot stuff effectively. But actually, if you look at a number of these waste heat sources, especially the kind of industrial process stuff, coming from chemical works or other heavy industry, where you'll see almost overnight that they're pulling out of either Hartlepool or Tees or places in Wales. I think that could be a really interesting kind of question. Not necessarily to say yes, an underwritten guarantee is the way forward, but actually recognising that is a challenge, that is a barrier. How can we work best to try and overcome that, recognise it, and get some of these things unlocked? Hen, do you mind if I just comment on the one that Simon was going to come to you on as well? So around the kind of thermal storage.
Please do.
So I think it's kind of a couple of things kind of coming together. So the impact of the storage contained within heat networks, the thermal storage that you choose to build as part of it, the fact that you're flattening out the peak loads on the power grid, and you're kind of accessing sources of waste heat that's probably driving increased performance of your heat pumps, and then those heat pumps are again kind of performing better. All of those things reduce that that load on the electricity system. So we've done an interesting piece of early stage high level work, and Joel was part of this, where we just took a sample size of say 2,000 homes and just worked out what the difference was if you did a building or a network level solution through electrification of heat, so heat pumps. And that initial finding suggested something like a 60% reduction on peak capacity requirement to service those same loads. And so we're definitely looking at more work to kind of be able to articulate the system benefits of a networked solution. And this is going to be a key consideration for our heat network zoning policy, where we think about where we're planning different interventions and how we're able to kind of quantify and monetize some of those system benefits to heat networks and to end users.
Okay, thanks very much indeed, John. Hen, is there anything you'd like to add in any terms of any of the questions that have been asked to you that you think you'd like to elaborate on so far, Hen?
So there's been one or two some questions from Jakob about using waste heat from hydrogen production, which I think is really interesting. I haven't been involved or seen much about it. I don't know if John, if you know if we're looking at that, but I guess as with all these waste heat sources, it's about location as much as anything. So as you were saying, Simon, about EFW, they tend to be far away, so you need a long transmission pipe. I imagine the same thing might be the case with hydrogen production, but certainly something that should be built into the conceptual design of these things.
Yeah. Okay. No, thanks very much. And I think there's an interesting question. I'm conscious not to ignore the questions earlier on. Darren McNulty, much further down, has asked a question about currently levels of UK energy resilience is very high. Thinking about heat resilience of the primary energy sources and via the fossil gas network or electricity grid. So I suppose it goes back to the very interesting question of whether there is a gas backup and top up component to those waste heat sources moving forward. I mean, certainly, in my view, unless we're in a different world, if you're taking heat off of an industrial site which has got a certain availability, let's say 94%, you do need to deal with that issue. John, I'm just wondering if it's possible to bring you in just to think about, the role in the short and medium term, as you said earlier in your presentation about gas backup and top up at an appropriate level for heat schemes, particularly in the Green Heat Network Fund that you expect to see coming forward?
Yeah, so I think in the short term, and you've mentioned the Green Heat Network Fund, we'd expect gas peak and backup to be part of the picture. But obviously we're looking to try and work the assets, whether that's the heat pump or the connection to the super low carbon heat, as much as possible to bring as much benefit as possible. And then kind of going into the future, it clearly depends whether we're going down a electrification or green gas kind of pathway. Clearly we've seen the deployment of electric boilers that are starting to provide that that peak requirement. And if we went down to hydrogen, then presumably the same thing would be provided by hydrogen boilers, which are already in existence. So I think short term, yes. Longer term, probably depends which pathway we go down.
Okay, good. Thanks very much. And just finally, I'm conscious we've got 3 minutes left. Georgios, hopefully that's correct, has asked a really interesting question at the very top of the chat, John. So this is really flagging up, as per my presentation. These projects are much, much more complex. They're not the same as, nobody's understating the complexity of building a gas-fired CHP district energy scheme, but introducing the component of sourcing the waste heat, resolving that as a solution, contracts, periods, timelines, and it's about public sector funds, and you're thinking about targeting some of those to project developers to allow them to, or co-support them to be able to investigate these new sources. Otherwise everybody kind of sits on the fence saying, hey, it's a really good idea, but my word, there's 10 times as much project development cost to investigate that project. I'll just sit on the fence until somebody helps me. John, does that question make sense? And have you got any thoughts?
It does, yeah. I don't think I've got a perfect answer, because I think we're probably in between sort of two bodies of support. So you might well have kind of found a critical barrier to wider deployment that we need to go away and think about. But broadly speaking, we've recognised that those people that are incurring potentially abortive project development costs need support. Traditionally, that support is going into local authorities through the Heat Networks Delivery Unit, and we've spoken, certainly over the last couple of years, about whether we can expand the remit to any developer that's looking to take forward a project, and those conversations are still ongoing. You've then got the Green Heat Network Fund, much like the Heat Network Investment Project, has got a kind of commercialisation part and a construction part. So, that commercialisation will enable, I guess, those more advanced projects to kind of finalise and close out some of those nuggety sort of issues that you've raised, Simon. But I think, it's not there to do the early stuff, working out whether there's a project and who does what and what's it going to look like. It's for a slightly later stage. So, one for us to go away and think about.
Okay, brilliant.
Can I just quickly just say something, Simon? I know you wanted to rush on, but I think we're trying to also see what we can do at a sector level. So as I say, there's a lot that can be unwrapped. There's a lot of issues which will be addressed, which will need to be tackled by all projects. And if we can do it at a sector level, like we're working with Water UK, we're working with a group of energy from waste providers, if we can try and work through these nitty-gritty problems more generally and then share them across the sector, that hopefully could reduce some of the transaction costs going forward.
No, absolutely. I mean, to me, this is about a conversation that the sector needs to have very widely. Really. This isn't going to be solved individually. And Suzanne just responding, the slides and everything will be accessible on our YouTube channel. Hen, just a final one, because I felt you've slightly got away with a few questions. John O'Shea has asked an interesting one. It's about if you've got agreement from the companies who are willing to supply waste heat, could that be put onto some kind of, I suppose, some kind of database? And as he says, it could feed into corporate social responsibility work. So it's a register of people who say, hi, we've got some waste heat, we're interested in having the conversation with people.
Well, I think that's a really, really interesting concept. I mean, like some sectors are doing that themselves. So like the TfL, the London Underground, have put together a project information notice, I think, where they've put it out to the market, what they're offering, which is, and we're sort of, as I say, we're engaging with Water UK on a similar sort of thing. Could that be done at a sort of more cross-sector level? I think it also actually plays into, John mentioned that's a part of the regulatory framework. We're looking at zoning, and that might involve, direct engagement with suppliers within a zone, requiring them to provide more information or encouraging them to provide more information that's publicly available and so on. So there are some sort of piecemeal ways of making this more accessible. But I like your idea of certification scheme, and we certainly take that away and have a think about it.
Brilliant. Thanks very much indeed. I'm conscious we're 1 minute over, so I don't want to be a bad chairman. So I will thank you both very much for speaking and also responding to questions. The questions are still coming in, so if you fancy a bit of typing afterwards, you've left the stage, please do. So thanks very much indeed, and a virtual round of applause to Hen and John. So thanks so much. We'll let you leave the stage.
Thanks.
Thank you very much.
Thanks very much. Cheers. Bye. So now on to the second session, and finally I get to introduce my partner in crime, Joel, who's been instrumental in putting this together. So Joel, if you'd like to come onto the stage. And Joel is a heat networks specialist from BEIS and has got some really interesting things to say, and hopefully giving you all a bit of a one-on-one on utilising waste heat in heat networks. So over to Joel. Thanks very much.
Thanks, Simon. Hi, everyone. Thanks for joining. Yeah, so I'm in the heat network delivery team in BEIS. I'm one of the heat network specialists. I have a similar role to Hen, who's just spoken. So today I just want to talk to you a little bit about how you can, what different types of waste heat there are, and sort of how you kind of get it and utilise it. At a sort of very high level overview, this by no means replaces the need to get some detailed engineering, because this stuff is a lot more complicated than I'm probably going to present it here. So I'm just going to start with the definition of waste heat. If this is teaching you to suck eggs, sorry, but I always find it kind of useful to just check that we're on the same page. So the definition I like to use is that it's thermal energy that's currently being rejected to the ambient environment. That could be rejected to the air, just hot air, wherever it might be, somewhere nearby, or rejected to rivers or sea, or possibly into the ground. And it's also worth noting that although most of this presentation and conference is really talking about heat in terms of the sort of hot stuff, it could also be cool. So, you know, if you've got a rejected supply of something very cold and there's someone that needs that cooling for something, then you could also use a heat network to grab that cool. I guess the main thing here is that we want to make sure that we're advocating the use of heat in an optimized way, and therefore minimizing it before we capture it. So what we don't want to be doing is encouraging waste heat just because we can then capture it and utilize it elsewhere. And a really sort of basic example of that is in a supermarket, they might have quite a lot of waste heat, but you might realize that they don't have very well controlled refrigerators. So you probably want their refrigerators to be controlled first, maybe consider doors or some other things to reduce the load on them before trying to capture that waste heat. Otherwise, it's kind of, it doesn't really feel that it's part of the whole picture and trying to drive towards a sustainable future and net zero. So as was briefly been touched on, particularly the last couple of slides of Simon's presentation, so the different types of waste heat, I would break down into two categories: direct use and indirect use. And direct use is when the temperature is high enough that you can use it directly. We could say here that's in excess of 60 degrees, but it depends on the user's need. And indirect use would be something below 60 degrees, and typically you'd use a heat pump to upgrade that temperature. So it's also worth noting that operating temperatures of heat networks is a contentious topic. There are lots of schools of thought on what temperatures they should operate at. And is it all about temperature as to whether it's direct and indirect use? The following example will hopefully prove that it's not, it is, but it's also not. So if we assume that you've got a 50 degrees C heat source, could be from anything, you could have direct use of it if, for example, you wanted 40 degrees C for a biological process. Then you could have a heat network, take that 50 degrees C heat, run it around whatever thing you want to warm up to 40 degrees. You don't need to do anything with it. Or if you're going to send it to a school and some other buildings that are probably quite old and need something above 70 degrees, then you'd need to use a heat pump. So I hope that kind of gives a appreciation for what we mean by sort of direct and indirect use, and it is really based on the actual end user's needs. And I think that's really key for a lot of heat network challenges, is that it's trying to match up how you deal with what the end user needs and what you've got as supply options. So I'll give you another example. This is probably getting a bit more into the engineering world, which may appeal to some of you and may not to others. So if we look at, I've got a sort of schematic here of a steam turbine, and I'm sure people can argue with me about the temperatures. These are sort of halfway between some sketches I was given and sort of some rounding. So, but just as a principle, you might have steam coming in at something like 430 degrees C, and at the different pressures of the turbines, you could take that steam out at, I don't know, either 180 degrees, 150 or 80, and use it directly for whatever that process may be. It's worth being aware that the steam that you take out of an electricity generating turbine, you then cannot generate electricity with it, because that's the thing that's driving the turbine. But the other thing to look at here is that on the right hand side of it, at the very end of the low pressure steam turbine, you'll have some kind of cooling tower. It might be an air cooled one, like in this picture here. I think that's an air cooled one, or it could be on a river. You might have seen the old sort of 1950s built coal power stations or nuclear power stations with the curved cooling towers on rivers or in the sea, and they can be between 30 and 50 degrees C. And you could arguably connect them to a heat pump and have an indirect source of heat as well as a direct source. And this is just to give you a little feel for, like, there might be a bunch of different applications that need different temperatures, and you could utilize some of this heat throughout this process for them, and where direct heat and indirect sort of fits in. So examples of sort of indirect waste heat recovery, I'm not going to go through all of the details of the diagrams that Hen showed. These sort of capture it generally. So this is looking at transformer waste heat, but it could be anything. And you've got this transformer in this box on the left. Apologies if it's a little bit small. I stole these straight from the reports produced by Arab. That might have some oil in it running at 40-ish degrees C. You might then have a heat exchanger there that then takes it out. It puts it through a heat pump. That heat pump raises it to whatever you need it to be, 60, 70, 80, 90 degrees C. The other form of indirect use could be that you've got something kicking out waste heat here, and you don't actually physically connect anything to it. You just put an air source heat pump nearby to sort of swallow the warm air that's there. So if you know that the air around something that's hot, well, it's kicking out heat, is always going to be at 20 degrees or 30 degrees, then why not shove a heat pump next to it? It would be better to take the heat directly from it and utilize it more at a higher temperature. But if for whatever reason, due to resilience issues with whoever owns that heat source, they don't want that, you could, in theory, just shove an air source heat pump somewhere a bit warmer than it would be if it was right next to your building, where maybe at the time when you really want the heat, it's probably below 5 degrees. So there's a couple of examples of indirect use of heat, because you'd have to raise the temperature with a heat pump. So just a little bit about how you might capture waste heat. So this is looking at capturing waste heat from gases. Please also put anything in the chat if if you've got any questions on this, or if I'm going too quickly or anything, or if this is just boring you to tears as well. So on the left-hand side, what you've got is a sort of what they call a heat recovery coil, and it's in some kind of flue stack that's something that where the flow of gas is just coming straight through there. And it goes through this coil, goes past the coil. The coil will have some kind of liquid in it, probably water. It'll warm up. If it's hot enough, you could use it directly. If that's sort of 300 degrees C exhaust gases, 400 degrees C exhaust gases, you could arguably get 80, 90, maybe even over 100 degrees C water out of that and use it for something. The other option is on the right-hand side, where you might want to have some kind of bypass arrangement. So, or maybe you can't fit the heat recovery coil into that thinner tube on the bottom. So you put some kind of dampers in the way, you put a much bigger thing on top of it, and you try and direct the air around it into your heat recovery coil. But you might also want to have the ability to not necessarily send heat through your heat recovery coil when it's not needed. And if I'm not mistaken, I think this was stolen from a diagram of how some of the heat recovery on the underground looks. So that's heat recovery from gases. Heat recovery from liquids is probably a little bit easier, because all you'd probably do is you've got something that you need to cool, which is your cooling load on the very right-hand side there. You'd stick a three-way valve in there, so it allows you to bypass your heat exchanger if you don't want to use it for whatever reason. But hopefully you would send most of the heat through the heat exchanger, and you could use that to warm up whatever liquid is running around your district heating or heat network. Or if you need to, if it's not hot enough, you can then put it into a heat pump and raise the temperature. You could also, as the previous slide showed, avoid this sort of three-way valve arrangement and just always send it through the heat exchanger. And that just depends on the needs of the application at the time. As was already mentioned, there's issues around resilience here as well. So if you're tapping into someone's existing cooling load, they might want to make sure that they can still use their existing equipment to cool things down if your heat recovery equipment fails for whatever reason. So we're just going to go through some of the sources of waste heat. I think one of the easiest ones to think of in my mind is cooling as a source of waste heat. The sort of mantra here is, well, wherever there's cooling, there's waste heat, because you're taking heat out of something in order to cool it down. Sounds kind of obvious, but it took me a little while to get my head around sort of how to think about cooling in the context of heating. And this could be chillers, I don't know, food storage like in the picture. It could be any sort of forced air arrangement where you're blowing air over something to cool it down. Some forced liquid arrangement, like maybe you could think of the oil going around your car engine into the radiator, or on a bigger scale, it might be a much larger engine. You've got cooling towers, so that could be power generation or other processes. Any vents from anything warm, so something like a commercial kitchen, you could consider that a waste heat source. Maybe not necessarily a particularly large waste heat source, but still a waste heat source. And any kind of gas compression releases heat, because when you squash a gas, it gets hotter. So I hope next time you go to the shops and you look at the fridge there, whether it's because you want to pick up something healthy or you're treating yourself to something, you then think about actually every time you're opening it, you're actually generating waste heat. Other sources to think about are sewage and wastewater treatment. So it's not the most friendly topics to talk about, but effluent does generate heat. The biological process there produces heat. Exhaust gases from any kind of combustion process, underground railways such as the London Underground, any drying processes, and electricity distribution as well, because electricity distribution, all losses in electricity systems are pretty much heat. So what might this look like? Now, appreciating that this table doesn't have the same category as I looked at before, but we had a list of assumed source temperatures from the piece of work that Hen was doing. So if we look at this top red section, you've got high temperature sources like crematoria, cement factories, lime factories, iron and steel. All of these, well above 100 degrees C, you could just shove them straight into your heat network. That's assuming that your heat network, we're talking about sort of above 60 degrees C heat network. If you needed higher temperatures and it's a steam heat network for some other process, then you need to think about the right temperatures there. These ones in the middle that are kind of yellow and orange, these would need a heat pump. So these could be things like cooling around substations, data centers, mineral industries, chemical sectors, food and drink, paper and pulp. It's worth being aware that the food and drink sector, as we'll probably hear about some of the case studies, is very wide, with a wide range of different waste heat temperatures within it, depending on what's being produced. So these are really just good guide temperatures. But what's important to see here is that all of those you can achieve really high COPs. And again, it's another contentious topic that engineers will probably argue about till they're blue in the face. But let's go with, you can get COPs between 4 to 7 in that, which is that 1 unit of electricity in will kick out 4 to 7 units of heat out, assuming that heat is available from that waste heat source. You've got the cooler sources at the bottom, so like the supermarket refrigerants, cold stores, underground railways, water treatment works, all around 20-ish degrees. Now, if you want to think about this in comparison to, say, if you put an air source heat pump on your home, how hot do you think the air temperature is most of the time when you want heat? Okay, in the summer when you want hot water, fine, it might be 15 to 20 degrees. But when you're doing your heating loads, it's probably below 15 degrees. For a lot of the time, it might even be below 10. And all of these mean that your comparative COPs of an air source heat pump in your home might be, or even an air source heat pump on a smaller heat network, might be anything from 1 to 3. And these sort of arrows on the side here, it's a bit of a busy slide, it's just trying to say, look, as the heat source temperature goes up, the COP, the coefficient of performance of your heat pump, goes up, and the electrical demand goes down. And that's important because when electrical demand reduces, it reduces both the emissions content and the carbon content of that heat. It reduces the demand on the network overall, and there's in the electricity network, and it just helps us provide a more sort of sustainable energy system where we're utilizing our resources as best as possible. So just to wrap this up, there's quite a few different things we've covered here. So waste heat can be used directly or indirectly. There's different ways to capture it, if it's a gas or a liquid. There's lots of waste heat sources out there, and high temperatures are good. And they're good because they reduce electrical requirements of heat pumps, which then reduces emissions, and it reduces demands and impacts on the grid. So I think that's the end of my presentation. So I'd just like to thank the UKDEA, my colleagues, and the speakers who are going to come up shortly.
Brilliant. Thanks very much indeed, Joel. Really, really interesting and good 101. I know you didn't send me to sleep. It was I had learnt a lot, but also you've got some very intriguing questions in the chat. So let's deal with those after the next session. So if I'd like to invite Joel to leave the stage, and we'll do the Q&A after the 3 case studies. Joel,
Thanks.
and thanks very much, Joel. And I'd like to invite Gareth Harcombe from Cardiff City Council to join me on the stage. Gareth, if you're there, hopefully you'll join us, and to talk about the Cardiff Waste Heat project. Gareth is the Energy and Sustainability Manager for Cardiff City Council. So over to Gareth.
Hey, thanks, Simon. Hi, everyone. As Simon said, I'm the Energy and Sustainability Manager for Cardiff Council. We've been running this project now for a number of years, but we're really at the point where we're just about to start work, which is great news. So just a little bit before I start on why a local authority is doing this. We've been in the carbon reduction arena for a little while, and I've actually declared a climate emergency. So there's a big strategic document called One Planet Cardiff, which is set an ambition for the council to be carbon neutral by 2030. So we are ourselves, a number of our buildings are going to be customers of the heat network. So we were really interested from that perspective, because it's actually a very cost-effective way to decarbonise heat. But further to that, the Welsh Government has actually set an ambition for all public sector in Wales to be carbon neutral. So we're very much motivated by that as well. And obviously we are fortunate in having this local opportunity to use the city's waste to heat the city's buildings. So there's some great kind of energy security, circular economy stories there as well. So our members are very very enthusiastic about the scheme, I think it's fair to say. So this is just a little bit of an infographic about what we're actually building, and relates back to some of the stuff that Joel was saying actually. So you can see there that our heat source is the Trident Park Energy from Waste facility. That exists. It's been there for 3 or 4 years. It's consuming the non-recyclable waste of the region, actually, not just the city. It is already creating about 30 megawatts of electricity. But there's potential, and there has been all along, for 15 megawatts of heat. So this is what the project is based on at this stage. So our funding will install the heat exchanger in the building. So that's the kind of the second circle along from the left there, and that will capture turn the heat from the steam into hot water. That is then pumped to the next circle along, which is our backup energy centre. So that's where pumping happens, where there's big, large hot water storage tanks for resilience and for peak demands. But there are also some gas boilers there that kick in. The energy from waste plant obviously closes for a week or 2 a year for outages and that kind of thing. So in those moments, the gas boilers can kick in to ensure resilience to the heat network, very much as a backup and not as the heat source. And then the big civils project really is to install the insulated pipes underground to the heat distribution system across the bay mainly, but it does reach into Cardiff City Centre. and can connect to a whole host of buildings in which there's also heat exchangers, and then that heat is then distributed through the existing wet heating systems in those buildings. So just a little bit about the project history. The energy from waste plant arose from a procurement which was a regional one done by a collection of local authorities. And the question was, now that we can't go to landfill, what do we do with our waste? So we weren't asking for an energy from waste plant, but that's what the optimum solution from that procurement was. At the very start, the company themselves were looking into a heat network, but that didn't progress very far, I think largely because of the need for grant funding. But by then, we had, and I think it was actually pre-HNDU, but I might be wrong, but it was very, very early anyway. But we'd had some funding to look at how we reacted as a customer to that proposal. But then when the commercial route sort of became a bit difficult, we converted that fund to investigate the potential for putting the council in the lead to engage. So since then, we've had quite a journey of developing feasibility and a wider city master plan, which looked at other potential sources of heat across the city. It settled on this one as being the optimum one for now. And an outline business case was approved by the council a couple of years ago. That gave us authority to go on and make the final business case, which is all done now. That supported our capital funding applications and triggered the various procurements that we've gone through. And throughout that, we've, using the HNDU funds, we've been supported with expertise from the Carbon Trust, who've helped us along the way. So this is the heat network. The map on the right there shows the heat source, which is the energy from waste plant. The red line is the network that we actually have funding for, so that's phase one. And then the black line is the potential that the available heat at the energy from waste plant could serve, we think. So the black line is probably subject to change, but the immediate project is to deliver the red line. Our whole business case is entirely predicated on just public sector customers, and there are 4 of them. So the council has a number of sites, and then there are 3 others. The Senedd, which is the Welsh Government's headquarters, the Millennium Centre, which is a big arts facility, and Cardiff and Vale College, which is a big tertiary college, and then there's some other council buildings along the way. The reason we've done that is because they are the sorts of organisations who can sign up for the long-term contracts that we need to underwrite this risk, and they're also driven by the same carbon policies from Welsh Government as we are, because they apply to the public sector. So our business case, as I said, is based on just those 4 real customers. They've signed memorandum of understanding with us, and we went that way. It made the business case very, very difficult, obviously, because there's a lot of upfront investment and few customers to supply. But we also thought that it gave certainty and credibility for future customers that the likes of those were involved. So that's the network. However, what this map shows is all of the commercial opportunities around that network. So all the black dots are existing buildings, and the green circles are major redevelopment sites. So once we have established the heat network based on those customers, we have the longevity and the underwriting of the risk that we want. But there's many more customers who are already showing interest in joining. And actually, Welsh Government planning and planning policy has just changed really in our favour, really, and I think it's going to be a lot easier to persuade developers that this is the right thing to do in terms of carbon reduction and the climate emergency. So just finally, we've successfully secured our funding for the project. So that red line that I showed in the plan earlier on costs about 15.2 million, and it's made up of a grant from HNIP of 6.6, and we've been very fortunate as well to get a loan from Welsh Government, which has been provided interest-free over 35 years. So that's all in place. We've established the Cardiff Heat Network Limited, which is a wholly owned council company, but it's a special purpose vehicle to operate the network. And that was, well, as well as being a sensible thing to do, it was a requirement of the grant funding. We've been through a major OJU procurement and now have a design, build, operate and maintain contract procured. And where we are at the moment is that there's a whole bunch of agreements that need to be signed effectively the same day. So it's the heat purchase agreement from the energy from waste plant, planning consents, the heat supply agreements, a couple of way leaves. So we're just going through the very final kind of governance procedures on those. And I'm hoping to have final sign off in the next couple of weeks, actually. So we have an official live project from June 21. There's a 3-year build program for phase 1, and we're hoping to have the first customers connected in the spring of 2023. So that's a very quick run through the project.
Brilliant. Thanks very much indeed, Gareth. That's really, really great. You could present on the project. I'm not sure that many people have heard you speak before, and there's certainly some good feedback and questions in the chat, but we'll go to a Q&A session shortly. So if you could hang around and for now leave the stage, I'll introduce the next set of speakers. So thanks very much indeed.
Okay, thank you.
Cheers. So we have a double act coming up now, talking about heat from the underground, the Islington project, which many of you will have heard about, but maybe not had people speak about. So we've got Rodrigo Matabuena, who's the Energy Capital Project Manager for London Borough of Islington, and also we've got Graeme Maidment, who's the Professor of Heating and Cooling at LSBU. I will leave the stage and leave the pair of you to manage it as you choose, gentlemen. So over to you both. Thank you very much indeed.
Thank you. Thank you very much. So should we? Yeah, this is a double act, as you all say. And anyway, I'm going to start giving you. We start the presentation, and ultimately, what we the aim of this presentation is to give you an overview of the journey that Islington is being through in using and developing projects in general, utilizing waste heat. Obviously, we're going to be talking a little bit about Bunhill, which is the flagship project that we've got at the moment. But then again, this presentation is going to be centering to the journey that we've been through, what's being what's being done in the past, what we've got at the moment, and what's the future of energy recovery for Islington. So pretty much as the same as Gareth was mentioning, just before Islington back in 2019 declared climate emergency, and on the back of that we started developing what we call now the Vision 2030, which is our public commitment of becoming a net zero carbon borrow by 2030. This is obviously very, very ambitious and very challenging in many ways. And we believe the heat networks are the core of whatever we need to do to make this happen. We believe in heat networks not just because, well, it's one of the best and most effective ways to facilitate the transition to low carbon technology, particularly around the all communally heated systems, all the communally heated council estates that we've got in the borough. It's the best way to facilitate that transition. And we see heat networks not just as a mechanism for decarbonizing heat, but it's also part of the infrastructure that we are building for the future. So the more and the better heat networks that we've got in the borough, the best we're preparing Islington to adapt and to be a resilient borough in the future, and to benefit for the most up-to-date technologies in terms of low carbon heat. Our journey began many years ago. The first heat mapping that we commissioned and we started developing was probably around 2008, 2009, we kept fine-tuning some of the clusters that were suitable for heat networks. And back in 2013-14, we commissioned the centralized energy master plan. And but before that, we had the idea of before the master plan. Sorry, the master plan came a little bit later. But by 2012, we commissioned the first heat network. So the first energy center. Bond Hill 1, Bond Hill Heat and Power is the name of the network, and at this time it was one single CHP engine, 2 megawatts, so relatively well, big scale of things, but it wasn't that big. We were providing heat for about 600 council homes, 100 private homes, a couple of leisure centres, and it was a real success. Again, it's a 2 megawatt CHP engine, but it was very, very successful from many points of view, social, political, and obviously the environmental at the time. Bear in mind that in 2012, CHPs were still considered a low carbon heat source, and so that encouraged the council to move forward and to create Bond Hill. So Bond Hill probably we started developing Bond Hill conceptually around 2014, and in 2016 we started working actively. We started the construction of Bond Hill. So this is the first, at the time it was the first of its kind, the first time we were collecting, or we were capturing low grade waste heat from London Underground. The plan was to build this energy center with a 1 megawatt heat pump plus 2 small CHP engines, and this center was is connected to heat and power, to the network. So effectively, we have a larger network today with 2 independent energy centers interconnected, and with a much more flexible generation matrix. In this case, it was a great opportunity for us to work along TfL, specifically with London Underground branch. As you may know, if anyone have been in the tube recently, especially in the summer, you probably experienced the severe overheating problem there is in the tube, especially around the central London stations. So overheating for the tube for London Underground is a major problem, and they have a number of vent shafts around the city, and it was a great opportunity to try to capture some of that waste heat and at the same time provide them with some cooling. So basically, the system is relatively straightforward. We have a CHP, as I said, we have a heat pump, and we have the head. You can see here in this picture is as basically the building with 3 containers stacked one on top of each other with different components. The heat pump, CHPs, and on the right side we have the head house where we have the coils of the heat pump. So we're extracting all this heat and then injecting it into the network. The heat pump boosts the temperature from the 14-21 degrees. That's the range that we get from the tube, and it boosts it to 75 degrees. So Bond Hill, as exciting as it is being challenging. I'm not going to lie about it, and it's been taking us a while to commission the project, but it is almost there. So we're in the very final stages of commissioning and fine tuning it, and it's ready to go. Now, this is, as I said, this is part of the journey, and this doesn't stop here. So now this is something we've done, and we're really happy and excited about this part of the process that we've been through. Is being a success in many ways. Yes, it's taken us a little bit longer than expected, but ultimately it is a project that we're extremely proud of, and actually encourage the council to move forward and to keep expanding and building on this. So I'm going to let Graeme to talk about the future. What is the future of Islington? What Islington is looking into right now, and what we're expecting to have based on these experiences about Bond Hill, and what is coming in the future, very near future.
Thanks, Rodrigo. Hi, everyone. It's Graeme. I just just wanted to sort of update a bit from where Rodrigo got to. So Rodrigo was talking about sharing heat between applications, so taking heat from the tube, cooling the tube and using it elsewhere. But waste heat opens up other opportunities as well. Using decarbonised electricity, using heat pumps is a fantastic opportunity to decarbonise. And also this Venn diagram also talks about the opportunities to have flexibility through storage. And by doing that, the combination of sharing, prosuming and using flexibility, significant opportunities to reduce cost and carbon emissions. On the right hand side, you can see the opportunities from heat from the underground, and in terms of gigawatt hours, and in total the amount of heat that's available from secondary heat sources is massive in London. And below that's a diagram that shows, it's a graph that shows opportunities for a range of different heat sources. The big circle there, so the graph shows temperature and the amount of heat that's available. The big circle there shows data centres. This is a piece of work that my colleagues Akash and Enrique have produced, and data centres are a real opportunity. This brings me to the next slide, and I want to talk about green skies. Green skies is a way that we're exploiting the opportunity for heat from the underground and from data centres. You can see on this infographic here, it shows, developed by Cullen Studio, it shows the concept. It's a 5th generation heat network, which is at ambient temperature. So the pipes in the middle there is a heat network at ambient temperature. That means we can capture heat from different heat sources. In this case, heat from the tube, heat from data centres. But not only that, we can use renewable energy when the sun shines and there's an abundance, or local generation of electricity behind the meter with PV, means that we can use electricity in a very low carbon way. And the whole brains behind that is controlled with sort of machine learning, flexible control, smart control that allows us to share energy, to use it at the right times, at the best times. And in doing so, Green Skies is able to deliver against our vision. Our vision is about using clean energy, using cost-effective energy, and developing schemes alongside the community. And success for Green Skies is when we result in construction and it being copying. I wanted to talk briefly about construction. Construction we're learning by doing in Islington. We have a specific scheme which we've called New River. This shows geographically on the left-hand side where it's at. It's in Northumberland Square. And the right-hand side is Professor Phil Jones's concept that he's produced, tremendous. And it shows the size of the heat pumps and the thermal stores and how we connect with batteries and mobility and a whole bunch of stuff. And in doing so, we're able to deliver massive benefits. And this bubble chart shows the sort of savings that we can save in Islington with New River, and it's around about 1% of the carbon emissions can be saved by switching to a Green Skies system. Okay, but at the same time we can address fuel poverty and lots of other benefits, including environmental particulates, etc. But we just don't want to do it in Islington. We want wider replication. We see a fantastic opportunity. The figure at the top, you can see again, is produced by Phil, and this is about how we can exploit this Green Skies systems across Islington. And you can see the green line boundary, as he calls it, is about a quarter of Islington. Potentially 50,000 consumers could connect into Green Skies system. On the right-hand side, you can see the work that we're doing in Green Skies, and this is by Chris Dunham. Hopefully, he's on the call as well, from Carbon Descent. And Chris is looking at how we can map potential heat sources as well as potential heat demands. And if we can map this in an integrated way, we can make the design, the integration, the development of Green Skies systems much easier. And on the bottom, you can see potentially what the opportunity can be. This is a slide that's been produced by Enrique and Akash, my colleagues, but basically shows the opportunity in councils that have declared a carbon net zero carbon climate emergency by 2030. Hydrogen won't be available, so they're going to need to use heat pumps. And by 2030, 2030, and 300 of the 400 local authorities have declared net zero. Many of them mention heat networks, and we see a real opportunity to deliver low carbon heating, cooling, mobility and power in these networks using green sky systems. I think we've probably overrun, but just last slide is really just to recognise that we're part of a team, and a big team with lots of partners there. Can't mention you all, but it's a fantastic team. Look forward to answering your questions. Thank you.
Lovely. Thank you very much indeed, Graeme and Rodrigo. I'll let you leave the stage because I'm conscious that we're running up to time now, and I need to invite the next speaker on. But thank you very much to both of you. So Graeme and Rodrigo, just the cross in the top corner of your image, if you'd like to press that and leave the stage. Thanks very much indeed. So yeah, just to focus, the previous speaker's core message was about heat from the London Underground. So if we'd like to take questions on that, I see there's already one from Nick Allen in the chat. So we'll now move on to the next speaker in case studies. Yeen Manders is an independent consultant, and his presentation today is about the untapped resource. So heat from sewage works, a bit of a mystical thing that hopefully Yeen will be able to pull back the veil on in his presentation today. So over to you, Yeen.
Great. Okay, thank you, Simon, and hello to everyone. There's a lot of people in the audience I know, and some of you have been working on this project. So hopefully you'll like this presentation. The untapped resource, heat from sewage. Well, you know, where there's people, there's sewage, and you know, this is a source of heat in urban areas, which is really at the moment we barely even, you know, there's no, at the moment anyway, there's no systematic way of actually exploiting this waste heat in the UK. But district heating networks are the obvious way to do that. Just to introduce myself, because many of you know me, I've been involved in district heat networks for a long time now. Back when I worked for ACE, I worked on drafting the Planning and Energy Act 2008, which gave the powers to local planners to order that district heat networks are connected to new development, or rather order new developments are connected to district heat networks. That act is still in power. There's been various attempts to amend it, but generally they leave the district heating network parts of it alone. Then more recently than that, I was involved in the industry big offer to Ed Davey. This is the only photo I could find of me and Ed in the car park of Kingston Hospital. That will come up later. And then more recently, I was involved working for the Danish government in enabling the MOU to be signed between Scotland and Denmark. And Denmark has been thanked explicitly by the Mr. Wheelhouse, the Scottish Minister of Responsibility for Energy, for being involved in the drafting of the Heat Act in Scotland. But I'm a resident of Kingston, and I've been involved with energy in Kingston for quite some time. There's not really very much information out there about the extraction of heat from sewage. There are several projects around the world, but in the end, you know, this is something which has not really been taken up, probably because the temperatures are relatively low. But the important thing about extracting heat from sewage is there's a huge quantity, as it were, of embodied heat, you know, from the sewage treatment process, and it's there basically to be exploited. So I put a few schemes there on the left-hand side. Stirling is the one I know the best. I went up to visit the Stirling scheme. Very interesting one in Scotland, and they're also at least planning another two more that I know of. Paisley, which I know is under development, and I've heard of another project under development in Scotland. So good things being done in Scotland. There's really three ways you can collect heat from sewage treatment or from drainage. One is in the sewer itself, but that's, you know, in a local sewer, but that's really only a very small quantity of heat you can get out of that. That would be kind of suitable for one building. The second way is to collect the heat out of the sewage network just before it goes into the sewage treatment works, and that's the system that they're using in Stirling. And you know, there are advantages and disadvantages of that. the main disadvantage being that you're dealing with untreated sewage. So you get a temperature of about 10 to 12 degrees out of that. But what we have been working on in Kingston is extracting the heat after the sewage treatment process has occurred. So from the final cleaned up water, which is ejected into a watercourse, and that's what we've been doing in Kingston, and that treatment adds about 2 to 3 degrees on top of that, the temperature of 10 to 12 degrees, which you would get if you extracted the heat before you went into the sewage treatment works. I'm just trying to work out how I can move on to the next slide. Here we go. Obviously, I live in the London area. Thames Water is an enormous water company, the largest in the UK, and has got 15 million, customers. I mean, it's that's an enormous number of people. It's an enormous area that it covers, and most of the densely populated areas really of the UK, Thames Water covers. So it has been estimated about the amount of waste heat which comes out of the Thames Water plant, and someone from Fairheat estimated last year that would be about 10 terawatt hours annually. So there's an enormous amount of heat there that could be exploited, and water companies are interested in this dialogue. They want to improve their environmental image, and they're also looking for new sources of income. So certainly it's been an open door with Thames Water as far as we're concerned with the Kingston project. So it's something which I know the industry is looking at, the water industry as a whole is looking at this issue, and I know the BEIS are involved in that. So hopefully good things will come out of that. Moving on to Kingston. I mean, in terms of the Kingston area, there's a Thames Water plant, the Kingston wastewater treatment plant, and that produces about 70 million litres of wastewater a day, which it injects into a local river called the Hogsmill, and the Hogsmill feeds then into the Thames. And that water, injected water, is about 10 to 15 degrees higher than the environment. So with that volume of water and those temperatures, there's obviously something that we can exploit. And the project that is happening in Kingston is based on renting a small area of the Thames Water land, just before the water is ejected. And the first slide I showed, the subject slide, showed that ejection point into the Hogsmill. So there would be a sump built, which then the water would be diverted into, and then the heat pumps would sit in that warm water and extract the heat. And we were planning on raising the temperature between 60 and 70 degrees because the ambition of the district heat network in Kingston is to ultimately join existing buildings as well as new buildings. So the good thing that we had in Kingston is a first customer, which is the Cambridge Road estate. So that's going to be a rebuilt council estate about 500 metres away from the source of the heat in the Hogsmill River. So very short distances involved, and then the idea then was to take the heat onto the Kingston Hospital in the first phase. And can I say that Kingston's been very generously supported by the government and the GLA on this project so far. So thanks go to them. So here's the map of the Kingston scheme. So Kingston is a very compact urban area. Used to be a county town, so there's lots of public buildings in Kingston. And phase one is that square on that blue rectangle on the right-hand side. So you can see in the bottom of the square the water source just before it's ejected into the Hogsmill River. Then we would go across a graveyard. We'd be passing a crematorium, which the plans are to connect that up ultimately. But it's only a very small source of heat, about 200 flats you could heat with a crematorium. Take it north through the graveyard into the Cambridge Road estate, and then further north up to Kingston Hospital. But there are also some new developments in Kingston coming along, which the council has under its control because they're council-owned land. And there needs to be a feasibility study to make those connections to those sites. We also have another potentially very large customer with Kingston University as well. So that's a project really in a nutshell. I've put various sources here There's also a very interesting article from CIPSI about the Kingston scheme, which I haven't listed, but I'll talk to Simon about circulating that information afterwards. Just in terms of the people involved in the campaign, the project so far. So we had Bureau Happold have done really all of the technical and the commercial work on the project. We had Avico as the project manager, who also did a recent application to HNIP. And myself, I was working on the liaison really between the consultancy team and Kingston Council. So if you want any more information, please contact me about it. Thank you very much.
Thank you very much indeed, Ian. That's a very interesting project, and as you say, it's not one that people know very much about. So, Ian, if you don't mind staying on the stage, you seem to have disappeared from my feed for the moment, but if you can stay on the stage, Ian, and if I can ask Gareth, Rodrigo, and Graeme to rejoin us on the stage, and as well as Joel, importantly. Joel, are you there for a Q&A session? So I'll wait for the speakers to rejoin. Gareth, are you there at all? Hopefully you can rejoin us. We'll give Gareth a couple of seconds to hopefully rejoin us. Just in no particular order, let's go around a few of these questions. So Rodrigo, there's definitely been a couple of questions in the chat about how the scheme was worked in practice compared to your original projections, what COPs you're getting out of that. Would you be able to talk to us a bit about what you're getting in practice?
Sure. Unfortunately, the network hasn't been up and running through an entire heating season, so we still don't have that information. That's a reality. That's a truth. We haven't been able to compare fully all the data sets from the actual operation of the network against the projected against our models. However, from the individual commissioning and testing of each section, independent sections of the network and plant rooms, yes, pretty much there is a very good correlation. So we are expecting to have from the models we generated initially, we had to tweak slightly the models, so we had to adjust the models slightly throughout the development of the network. But there is a very good correlation so far. So we're expecting it to be the case once the network's up and running. Would you be able to share, or is it possible to share now the sort of the COP that there's a few questions been asked in the chat about what sort of COP you're getting out from the heat pump on the tube? Is that possible, Rodrigo? Yeah, at the moment, yes. At the moment, I mean, from the, I'll be happy to share some more specific technical information. At the moment, I mean, the COP of the heat pump, I mean, it's assigned to have a minimum of 4.2. The COP of 4.2. We've been getting something slightly higher than that. That's due to some slightly higher temperatures. Again, this is because during the very specific testing and commissioning of the heat pump, and not throughout the whole year, but so we've been testing it in when we've been getting slightly higher, the high temperature season of the air coming out of the tube. But yeah, we're getting COPs up to 5 actually, 4.9, 4.7. Yeah,
that's very positive. Thanks very much indeed. Joe, can I pass over to you? There's a question at the top of the chat that you may not have got to. It's about heat from a steam turbine is considered to be waste. I mean, there's an interesting question about how BEIS are assigning that. So I can leave you thinking about that for a minute, unless you want to answer that one. No.
So I should probably say that I didn't probably say that slide as clearly as I could have, and it was really just kind of showing the concept of sort of direct use and indirect use. I wouldn't necessarily. It's actually quite a tricky one where you kind of quantify what waste is when you look at a steam turbine, because if you wait until the very last stage of it, where you're going to the condenser, it is then waste. Then if you were thinking about maybe trying to take that heat at the condenser and use a heat pump, you might end up using more electricity than you would do if you were to take sort of the very low pressure steam and take that out and generate heat with that. You might find that your equivalent COP might be, like maybe 1 or 2 higher than what you'd have if you were using a heat pump. but it all depends on how it's been designed. So it's not, yeah, waste is probably the wrong term for that, but I think it's more about sustainable and efficient use of resources. But then I apologise if it came across as if I was stating that it's waste heat when you bleed steam at high temperatures off a steam turbine. It's most certainly not.
Okay. No, that's very helpful. Ian, you just happen to be next on my screen. There's a question from Dan in the chat about what role Thames Water have, and it's about the, essentially their role. The question's there, Ian. Are you happy to answer that one?
Yes, thanks, Simon. Well, their role, the plans to take heat, as it were, at the end of their process, just before they get the wastewater into the hogs mill, means actually it doesn't interfere at all with their processes. So essentially, they're there as an enabler. It's more efficient to put the sump where we're collecting the waste heat on the Thames Water land. So they're the landlords in that case, and they obviously have to cooperate with us as well. But the financial relationship has not been fully sorted out yet.
Right.
So there's still a discussion going on with Thames Water about that. But what I can say is that we've had an attention at the chief executive and the board level in Thames Water, and they seem to be very keen on the project. And clearly, this is a possible template that they could roll out in other sewage treatment works in their area.
Okay.
Simon, can I come in at this point on Thames Water and just add?
Yeah, just very quickly, Graeme. We've got a lot of questions to go through that have been posed in the chat.
Yeah, just Thames Water ambition is to become net zero, and by using heat from sewers and from wastewater provides a route for them to be able to do so. So it's something that we should encourage, okay, in their route to net zero. It becomes a win-win.
Yeah, no, completely agree. Gareth, there's been a couple of questions in the chat for yourself to do with sort of unusual questions, but hopefully you feel you can answer some or both of them. There's about state aid and also about engaging with private sector consumers and about what type of technology the energy from waste plant is. Have you picked those questions up in the chat, Gareth?
I think so, yeah. So the state aid one, first of all, yes, it is compliant. There's a certain exemption within the rules for heat networks, and within that, we obviously in applying for our grant funding, we had to explain that. So we have a council's opinion that's submitted to HNIP that they agreed with. Yes, so we are state aid compliant on that. Sorry, Simon, what was the next?
There was a question from Jodie about engaging with private sector customers. How are you getting on with engaging with private sector customers?
Yeah, so I think as I said in my presentation, our underlying business case is just with public sector and customers for now. And I think we've had a long and ongoing dialogue with them. But the things that have benefited that discussion have been the Welsh Government policy drivers for the public sector to be carbon neutral, which has been around for a little while now. So that's helped. I think, when a heat network is on the table and that's compared to other ways of decarbonising heat, it's very much more cost effective usually. So that conversation has been a good one, and more recently Welsh Government have upgraded planning guidance. So new developers are becoming much more interested in discussing this with us, and the planning system in the city requires there to be an independent energy assessment for any major projects, and I think that it's becoming clearer that this is a cost-effective way of doing things. In terms of hindrances to that, I think timing is always an issue. People need to replace boilers. Up until very recently, our timing has been, until you get the funding in place, you can't commit to when this thing will be there. So, both in terms of developers coming forward with their plans and their designs, and commissioning people to do those designs in the absence of us being able to guarantee a supply, that's been difficult. And yeah, just traditional, run-of-the-mill boiler replacement timing and that kind of thing. So those are the hindrances. I think as well, getting people to understand that we're selling energy as a service, not just as a meter reading, and that we are there's a need for us to maintain the equipment at their site, so that all helps as well. Yeah, but it's a long and an ongoing dialogue, and just need to keep that discussion going, really.
No, absolutely. Ian, there's a couple of questions that popped up for you in the chat, but I'll talk back to Joel. I feel that you haven't faced all the questions that have popped up. But would you mind? There were some questions about electricity recovery from transformers, actual COPs that you could expect in reality, and heat from supermarkets. Do you feel able to respond to any of those questions that were raised in the chat, Joel, or would you like to think about those and respond to those later in writing?
I've responded to a couple of them in there. I mean, just as a point, the supermarket question, I worked on a project which we were pretty far down the road, and then the supermarket decided to do some analysis of what would happen if they put some doors on their fridge plants, and it turned out that there wasn't enough heat for the heat network that we designed, which you would have hoped was picked up earlier, but it's always a challenge, and I think it's one of the reasons for this whole conference is that actually the reason why the waste heat is wasted in the first place is that it doesn't have appropriate value associated to it. And so whether it's a supermarket or a factory or anything else you're going to hear about throughout this process, throughout today's talk, it's really up to us to beat the drum about this as a low carbon, sustainable source of energy to then be utilized, because it isn't on anyone's radar, or even if it is, you do have a lot of hurdles. The supermarket is a really good example. There's a huge cost associated with a car parking space in the supermarket. So you've then got to convince the supermarket to lose a chunk of car parking spaces while you're building stuff there. Then you've got to make sure that the locals, this was already mentioned, wherever you're going to pump the heat network to, that supermarket's going to still be there. You've got complications of who actually owns the site. But then on the flip side, those supermarkets are part of a local infrastructure. They're part of a local community. They have a lot of ESG responsibilities that they want to try and promote. They want to actually make themselves look like they're supporting the local community. So if they could be providing low or almost zero carbon heat to local community centres, schools, hospitals, people's homes, that in itself is quite a useful, good news story that can be leveraged within the context of, there are the commercial desires, but they can be leveraged elsewhere. So I think it's quite challenging. And then on the COPs, I mentioned the names of a handful of major refrigeration heat pump manufacturers. I don't want to necessarily put any of them on the spot and state the values that I've heard from them, but the values I presented of 4 to 7 are ones that I've heard from multiple suppliers of large-scale heat pumps when you're operating within quite a small temperature uplift. So you've got a high-ish temperature source and a fairly low-ish, sub 80 degrees, 70 degrees heat requirement. And we heard from Rodrigo, this really nice high COPs that have been found on the Islington Bunhill 2 project. So they are achievable.
Okay, Rodri, thanks. And just finally, because I'm conscious we've really got to move on, Ian, there's a couple of sort of hard questions for you from Robert and Andrew at the very top of the Q&A. One was about the expected COP for the Kingston project, whether you know what the Sterling scheme was, and whether you could say anything or not about the price for heat for that. And what I thought that might cause you some chuckling.
Yeah, that's a good one.
We need to wrap it up there once you've responded, Ian, if you don't mind.
Okay. COPs, I think we were estimating that the water source heat pumps were 1 to 4, or 1 to 3. I can't remember. I'm not an engineer, but anyway, we were using conservative figures in terms of the heat pumps. But as everyone knows, the technology is improving all the time. When it comes to heat price, that hasn't been negotiated. Now, clearly this is waste heat which is thrown away, by Thames Water, and you could argue, raising the temperature of a river, about 2 or 3 degrees in total, just before it gets to the Thames. I mean, that's not a natural environment anymore. So, we would expect it to be a very low price. Let's put it that way. and we would expect the actual cost of the project to be primarily on the capital costs of actually building the system and the network. So no, I can't give you a price for heat yet. That hasn't been negotiated.
Okay, no worries. Well, thanks very much for all the speakers in this session. We are running a little bit behind schedule, so thank you very much indeed. A virtual round of applause. If I could ask you to leave the stage, please, and I'll invite Dominic Bowers to come and join us. Dominic will now be talking to us about the use of data centres and the use of waste heat. So, Dominic, if you're okay to join us, that would be very helpful. I can see your slides on the screen. I'll leave a couple of seconds. Brilliant. Thanks very much indeed, Dominic. So Dominic is Director of WSP and will now present about data centre heat recovery. Thanks, Dominic.
Thank you very much, Simon, and good morning all. Yes, Simon's asked me to speak a little bit about the potential for the recovery of heat from data centres and as a source for district energy schemes. This has come about because we're currently undertaking some feasibility work in Dagenham, which is a district energy opportunity area in Barking and Dagenham. And as part of that study, we're looking at a variety of different potential sources of heat for a network, including waste heat from data centres, and there happens to be a fairly large data centre in the study area. So, why would we be interested in data centers? Well, there's a perception that data centers offer a constant source of heat with little seasonal or diurnal variation. That's absolutely the case. You'll be, I think, familiar with the importance of data centers in modern life, in that we're entirely dependent on them for so much, including today's event. So yeah, they operate at very high levels of reliability. So therefore, this is going to be a constant and resilient source of heat potentially. And the other major benefit for data center heat is that it's actually at a higher temperature, so typically 30 degrees C or more, than alternative ambient renewable sources such as the ground, river water, lakes, or indeed ambient air. And that, as Joel pointed out in his presentation, will lead to higher heat pump efficiencies. As Hen was talking about in her presentation, there's obviously quite a lot of variability, both across different sectors with respect to heat recovery, but also within sectors as well. And data centers are no different. So there are various technologies used to cool data centers to keep them operational, and that's the graphic there is one I've pinched from Schneider, which quite usefully summarizes most of the current technologies that are used to do that. We can broadly split those into two types of system: those based on liquid cooling systems, where you've got chilled water, for example, as your thermal transfer fluid, or glycol, or some other form of refrigerant, or indeed air-based systems. The other thing to note is that, as you might expect, technology is moving apace with respect to data center efficiency, and there's a lot of work being done. In fact, I believe there are systems that are currently operational where they're actually using liquid to directly cool the server racks within the data centers. That's of potentially very significant, in that the temperatures that could be available from such systems would be probably in excess of 60 degrees C. So in Joel's terms, that would allow us to use that heat directly in a district energy network. So just looking at how we could recover heat from those two broad types, air to air and air to liquid. So on the right here, we have a fairly typical layout for a modern hyperscale data center, i.e., the sort of thing that Google or Amazon might be constructing and operating, with outside air coming in, being filtered, being cooled, and then being blown through the server areas, extracted via extract fans, and then exhausted to the atmosphere. In terms of the way that we would need to engage with that, or to utilize that, that would require us to install a heat recovery coil, again, very similar to the approach that Joel was suggesting, that you might use a coil in a flue stack. And that would allow you to recover the heat from the exhausted air, which is, as I said earlier, maybe between 30 and 45 degrees. What that's going to do for the data center operator is essentially put in some additional resistance in that circuit, and therefore that's going to require additional fan power. So that's potentially going to have an impact on the performance of the data center. You're going to need to use the energy performance will worsen, and indeed the environmental performance would worsen. There was some conversation in earlier presentations about the project development costs and the difficulty of doing these transactions. Well, given what I've just said, there are not a lot of incentives to your data center operator to allow this bit of hardware to be installed within their system, and I would suggest to you that makes doing a deal with them to recover the heat problematic. So looking at liquid as your heat transfer medium. So you've got, again, you've got a graphic at the bottom here showing how cooled air would be circulated through the servers and then returned and then cooled again. And you've got a cooling tower circuit supplying water at 20 and coming back at 30 maybe. The opportunity to recover heat from that circuit is probably requires rather less intervention. So you've got a heat exchanger here. So that would be cooling the water going into the cooling towers maybe by a couple of degrees and giving us 28-degree water that can go into our water source heat pump that supplies our district energy system. Now, the advantage here is that there is some benefit to the data center operator. We've reduced the temperature already before it gets to the cooling tower, so the fan power requirement will fall there. So there's a cost and an environmental benefit, and that gives us some opportunity to engage with the operator. I have to say that some of these remarks are based on some of the difficulties we've had in getting good responses from data center operators. I think you'll all recognize that the operation of these systems is highly profitable, firstly, but also any consideration that might impact on their reliability. I mean, the costs of, for example, some form of outage are almost incalculable for some of these operators, and therefore they really can't consider that. The opportunity here with this heat exchanger coming off this circuit is that the potential for any interruption in the operation is minimal. So how could we utilize this data center heat? Well, either in a centralized conventional DH network with a water source heat pump, or potentially in an ambient loop. I think the considerations as to which of those is appropriate are really locally driven. So they're all about the buildings that you're going to be connecting. Do they need the higher temperature that we'd get from the centralized plant system? Also considerations around whether or not you're looking to do a baseload supply or peak supply. Considerations around the space availability for pumping stations and so on. And also there's some commercial considerations here about the utilization of thermal storage locally within buildings. allowing you to access lower cost nighttime electricity and improve the commercial benefits of the project. And just turning to, excuse me, that question of the commercial benefit, Simon in his opening remarks was referring to the fact that we need to consider district energy against, or rather the appropriate counterfactual to consider district energy against is an individual air source heat pump, rather than the current counterfactual of gas boilers. And you can see from the graphic on the right that which is showing COP varying with air temperature, that we're getting, on average, we're looking at a COP of around 3 for an air source heat pump, whereas in the graphic below you can see, because we would be talking from, in a data center situation about essentially a constant source temperature, and that would be giving us a COP of 6. So there's a significant differential between those two, which could drive the investment in district energy. One of the things that I think we would be looking to water source heat pump manufacturers to do is to consider what improvements in efficiency they could get if they were just looking at a relatively narrow operating band, i.e. the sort of situation we have here, where we've got a fairly constant temperature source, and see what that would do in terms of reducing capex, improving COP, and also the operating costs of the units themselves. So the key messages with respect to heat recovery from data centers: there is a wide variety of data center types and designs, and there are different incentives for different data center operators, which are dependent somewhat on those designs. Local circumstances will dictate how best to integrate the data center heat recovery into your district energy network, ambient loop versus traditional DH, obviously. And there is this potential of liquid cooled racks offering potentially much higher temperature waste heat, 60 degrees plus, which obviously could have a significant impact on the viability of taking offtake from these data centers and supplying your district energy schemes. So perhaps that's something we should be encouraging our data center operators to engage with. Thank you.
Brilliant. Thanks very much indeed, Dominic. I see there's already a question in the chat, which we'll pick up in the Q&A, but thanks very much for opening up the window to data centers. So for now, I'll ask you to leave the stage and invite Mark Culley. Mark Culley is the Managing Director for JD Cooling, and Mark will now open up a window into industrial waste heat recovery through his presentation. So over to Mark. Thank you very much indeed.
Thank you, Simon. Yes, JD Cooling. I've worked here for probably around about, say, 6 years. The company was founded 2000 is probably to be precise. The range of products that we do, or engineering that we do, is mainly cooling process for factories, whether that would be for glycol systems, cold stores, freezers, plate freezers, spiral freezers, and all application that takes a lot of cooling energy and kilowatts of capacity. So, most of the systems that we engineer has a large heat rejection from the system that can be 500 kilowatts up to 2, 3, even 10 megawatts, depending on the size of the application. So I have a PowerPoint slide here of a way of utilizing heat recovery from an industrial process in a dairy, and a dairy that we've since installed in terms of the cooling of the dairy for obviously milk application. And that sort of cooling process was in the region of about 2.2 megawatts of cooling. So this slide will explain how the dairy process is achieved, how we cool it, and how we're able to harvest the waste heat to actually, place it into a district heat main, or in this case, we're using it locally to pasteurize the milk, to supply the heat source to pasteurize it. So if we move to the next slide, we have the process of milk that comes from our cow at the top. That will go to a milk intake plate heat exchanger on the left-hand side. That is pre-cooled. It then goes through to a regen section, which obviously recovers some of the heat that's of the milk during the pasteurization side, and it essentially ends up as a post-cool heat exchanger in the left-hand corner and ends up in a milk bottle, which we drink. So if we go through the next slide, we can explain the whole process of cooling, heating, and post-cooling, and how the refrigeration system achieves this, the energy that's recovered, and the ways that we can utilize or lift that energy to a useful heat, say 85, use an indirect method, which Joel referred to in his previous slides, that essentially saves gas, the natural gas. All refrigerants that we use for the industrial process will either be CO2, propane, or ammonia. Ammonia is probably one of the, I would say, the best choice of refrigerant in terms of its thermodynamic properties and its heat transfer rate, and is quite widely used in industrial processes, certainly of large cooling capacities rejection. So first slide here now, we go from the milk intake from the tanker. It comes into the heat exchanger. It's then pre-cooled to +2 degrees. We use ammonia refrigerant on the primary side to cool the secondary side where the milk product is, with heat exchangers or glycol fluid in our case. So we'll have ammonia as a primary fluid, and then cooling, the ammonia will then cool the glycol, which then cools the milk on the intake plate heat exchanger. So the heat transfer is taking place within the refrigerant medium. That will boil the ammonia gas, which is then recompressed by a screw compressor in this application, or a piston machine, because there are two different types, of which we then lift the pressure of the gas recovered to say 15 or 20 to 32 degrees design condition, which is then fundamentally rejected via either an air-cooled condenser, evaporative condenser, hybrid condenser, or even absorbed into a heat exchanger to a water system based. So all the energy that comes from the milk, essentially from the cow through the heat exchanger, ends up into the ammonia refrigerant, and then is rejected to the atmosphere, which is typically done in most industrial applications around the UK, worldwide, in various different ways. We then use a gas boiler to generate heat, clearly. That heat then is used to pasteurize the milk around about 74 degrees. And it then goes through into a regen section, into a heat recovery section on the pasteurizer itself, which uses the intake milk to preheat the milk. Then comes out of the regen section and then ends up into the chilled heat exchanger, which fundamentally will sit and end up reside in the milk bottle which we drink. So we're using different forms of energy. We're using electrical power energy in the refrigeration compressor to compress the gas that absorbs the heat from the product, which in this case is the milk. We then lift it to a temperature, in our case on this design, at 32, and it will range between a minimum condition of 20 degrees to 30 degrees, depending on the ambient, wet bulb, dry bulb throughout the year. So cooler in the evening and then warmer in the day when the sun is up, various parts. So we also then use the gas then to generate heat to do pasteurization. So we looked at an application here where we move to the next slide, that we install an industrial heat pump to recover that rejected energy, lift it from the 20 degrees saturated pressure or 32 saturated pressure to a useful pressure of +83. That will then give us 82 degree water off the other side of the heat exchanger that we can use for pasteurization. So therefore, we don't need the boiler to generate the heat source to do the pasteurization on the milk application. So we're recovering basically all the heat from the system as much as we possibly can, and using it as a handshake principle, where we cool on the milk intake we heat at pasteurization, and then we post-cool on the chill heat exchanger. So this application, what does it do? Well, it saved us 2.2 million kilograms of CO2 a year, and it was based on about 7,000 hours operation, and the COP performance was around 3.2, and that was lifting from 20 degrees gas temperature on the ammonia side to 86 degrees, which we do in a dual stage heat pack application. So it was very successful in terms of the application and the considerable financial savings that the dairy will benefit from could be in the region, depending on the unit cost and various other aspects, could be up to nearly £200,000 to £300,000 a year in natural gas saving, which obviously is very significant for the net carbon neutral moving forward, really. So how can this be used for a district heat main? Well, the principle can be still the same. You know, we have loads of industrial processes and plants around the country. This particular slide is showing a 2.2 megawatts cooling process for a glycol main, say for a factory. That would use a compressor in the same form in the previous slide to recompress the gas or the heat energy that's absorbed by the heat exchange surface. It will then be pumped up to a higher pressure and then rejected via a condenser medium format. So what we can do here is we can give you a heat pump compressor, and we can lift that, in this case, to 1.7 megawatts of heat, and that can be then pumped into a district heat main for 85 degrees of hot water generation, which is basically being sensible and useful for the energy that we're cooling. We can also heat in a handshake principle, which, you know, clearly would have some serious benefits, certainly for the industry and the environment. So I hope that was useful. My contact details are there. If you'd like to contact me directly, I'm more than happy to. Any questions on that?
Brilliant. Thanks very much indeed, Mark. That's really appreciated. I'm conscious on time, so if there's any questions from Mark, if you don't mind putting them in the chat. But Mark, if you don't mind leaving the stage, and we'll drop the presentation, and we'll now go back onto Cliff Bradshaw. Cliff is the Chief Executive of Copaxi Energy, and Cliff will talk through industrial waste heat, particularly in the food and beverage sector. So thanks very much indeed for joining us, Cliff.
Yeah, just about good morning to everybody, and I appreciate the opportunity to talk to you about heat recovery in the food and beverage. I'm a mechanical engineer, a chartered mechanical engineer, been working in the food and beverage industry for the last 20 years, and I run a company called Copaxi, and we're a bunch of chartered engineers identifying practical solutions in all types of industry. So this is content of my presentation, and it also is kind of the process that we follow when we're looking to identify and design solutions for industrial companies. So really quickly through the process, you know, it's all about optimize first. You know, so before we come with the really kind of blue sky clever solutions, let's do the basics. Just to touch on the sectors that this has applicability, the waste heat sources and sinks, and in this journey, it's all about matching these. And it's probably worth saying, actually, at this point, that, you know, a lot of this heat recovery I'm talking about here is it's not going out into a district network. It's being used locally in very much the way, you know, Mark has just described on that milk pasteurizer. It's all about understanding the process, and you need to do a mass and energy balance. Until you do this, you can't design solutions for heat recovery. Once you've got a mass and energy balance, you've got to validate that opportunity. And everybody talks about digital these days. So, you know, we build a digital model, run the simulations. Once we've got the data from that, we can design an integrated solution. And I talk about an integrated solution. So rather than just biting off one or two little heat recovery opportunities and having several heat pumps, if we can have multiple sources of heat integrated into a bigger energy solution, we can then bring all that together into and just use one heat pump. And then once you've done all that, you need to monitor the heat recovery performance. So that's the typical journey to net zero. I'm not going to dwell on this slide. These are all the ideas in the various categories in terms of low cost, no cost stuff that you should be doing. Standard technical solutions, and in this is heat recovery and free cooling. Let's do all of this before we go to our zero carbon solutions. Just talking about the target sectors, I've made a list of the food and beverage industry. We've touched on milk processing and really across all of these different sectors, we have similar types of potential heat sources. This is where you need to look to unlock the opportunities for heat recovery. And you've got to understand the flows and the temperatures and the locations to then understand how you would match that with the heat sinks locally. And that is quite a challenge. So we've just touched on flash pasteurization, and that is a candidate in every single type of beverage processing, certainly in the brewery, dairy, and fruit juices in them particular sectors. So these are all the different types of heat sources. CHP, hopefully bio CHP, we've got boiler blowdown, we've got a decent amount of heat coming from compressor cooling systems, and not to forget the process reject vapor from a typical process. Really quickly, there's a lot of detail on this slide. This is the level of mass and energy balance that we would do. I'm modeling a brewery here. What we have got, and I'm happy to share these Excel spreadsheets. This is a simple Excel, it's not simple, but it's an Excel model. And we feed in the master key data in terms of the throughput of the plant, the relative KPI performance in terms of kilowatts per hectoliter, which then calculates a mass balance then, and then pushes that primary energy consumption down into the relative transformation process like the boiler house. Quickly starts to identify to me, based on things like condensate recovery performance, what the heat sink would be to preheat the makeup water, what is the potential heat loss through the stack, and therefore the use of an economizer. So this is really, again, step one, looking at the direct heat recovery. It's used extensively in a brewery, in the vapor heat recovery section where the boiling the beer, called the wort. This heat is then recovered into a hot liquor system. If that part of the process is not optimized, then it will overflow, and it's absolutely pointless recovering the heat if you're just going to allow it to go down the drain. So step one, really optimize your systems. Then diving in to another level of the heat and mass balance. Again, these are all models that have been produced in Excel. This is almost identical process to what Mark's just presented. I'm pasteurizing pineapple juice here, the same process for doing milk. What we would do at this step is eke out all of the flows. So you can see the product coming in at 30, it hits the preheat zone, which during this deep dive audit, we found was completely incorrect. And I'll come back to that in a second. So by analysing this level of detail, we very quickly found out that this pasteurizer was poorly designed. And there was indeed a heat recovery opportunity right there in our face, rather than ditching that heat to a cooling tower, which was actually happening. And this is a live project that I've just recently seen in the last couple of months at Pineapple Processing Facility. From our mass and energy balance here, we can start to identify where we need to install some metering points, so that we can monitor this on a long term and also see the high increment data, measuring the flow rates, the temperatures, and ultimately using our sensible heat calculation is to make a profile of the relative heat flows. Only from this, then we can start to design a system. So we then take a shameless plug of our application strata here, that we build an exact copy of this pasteurizer, the juice pasteurizer, in our software strata, which is an IoT cloud application for modeling all sorts of heat systems. And you can see here where we kind of redesigned and put an extra plate pack here, and the hot product going out, in this case pineapple juice, is actually heating the incoming pineapple juice before it gets to the heat zone. So that was a fundamental mistake. We made that change and reduced the cooling load at the cooling tower. The purpose of doing this is so we then gather the data and we can start to design our system. And again, another Excel model, happy to share this, but this is a classic example of where you'll have multiple heat sources. So I can see I've got my juice cooler there. I've got 939 kilowatts. I've got some cooling from the powerhouse, where we're using cooling tower water to keep the air compressors cool. And then we've got some 2,453 kilowatts from process cooling. What we're doing here is we're bringing all of these different cooling reject heats into a water storage tank, a kind of warm water storage tank, and then we're using this at about 44 degrees, relatively high grade heat now, and pushing that through a heat pump, and then recovering that to the required processes in the manufacturing process. Again, unless you do the heat and mass balance of a detailed process, you can't really understand what the relative contributions here, and ultimately how you would use the heat that you've recovered. So taking that another step further, we would model that that heat pump in the box up here called heat pump, and then incorporate that with all the other heat recovery technologies, like the CHP, the biogas CHP engine, the absorption chiller, and how that feeds the relative flows in the heat network. And then finally, I know CHP has been a topic today. And you know, what we see a lot is people are installing CHPs, recovering heat, and it's not being used effectively unless we've got an effective monitoring system. Then we run the risk of not using our recovered waste heat.
Lovely. Thanks very much indeed, Cliff. I think a really interesting window into the various sources of heat in industrial processes which are going unrecovered. So thanks very much. If I ask you to leave the stage, Cliff, thanks very much. Can I invite Yeen Chan to join us? Yeen is a Senior Consulting Director from ICF, and he will give us hopefully some insights into the industrial heat recovery programme support program that BEIS run. So thanks very much, Yeen. Over to you.
Thanks, Simon, and thank you and Joel too for UK Heat Network History 101 and Technical 101 from Joel. And thanks to all the presenters on the interesting content. If you haven't guessed it, I've got an engineering background as well, so a geek in this area.
Yeen, I think we've lost you temporarily. If you don't mind joining the stage again, if possible.
I'm sorry, am I back?
No, no worries. Might be at IT. Okay, cheers.
Apologies. Yes. So my name is Yeen. I'm from ICF. We are the program delivery partner for BEIS on the industrial heat recovery program. And as Simon mentioned, I'll share a couple of lessons that we've learned from the program, and hopefully you find it useful. So first of all, what's IHRS? It's an 18 million grant funding pot to support identification and investment in waste heat recovery opportunities or industrial waste heat recovery opportunities. How did IHRS work? It's designed to be extremely flexible. So we encourage industry to come in at wherever point they are at in their project, whether they've completed a feasibility study or they need a feasibility engineering. If they've done, a preliminary engineering, and if they've done both, they can enter the scheme to get direct funding to support their project delivery. So we do that in phase 1 and phase 2 funding. So just to give you a flavor of what type of applications we've got in IHRS, I mean, typical ones were efficiency gains. There were a lot of replacement or redesigning of their existing system for efficiency gains. We fortunately got quite a few applications on, utilizing low-grade waste heat. And we've also got quite a few interesting ones looking into multi-point waste heat recovery from multiple sources, multiple temperature ranges, and different heat qualities. So highly challenging and always encouraging to see quite a few ORC interest there as well to electrify low-grade waste heat. We had a very interesting commercial carbon capture and utilization project. And relevant to heat networks, we have been looking at quite a few data centers on sharing of energy resources, either through a cluster or internal heat networks. So, and a few more interesting ones like, yes, phase change materials and most of this low-grade waste heat opportunities actually require quite a complex commercial arrangement and they're usually very challenging. This is just a snapshot of the applications that we've got, slightly outdated, but still relevant because the profile is slightly the same, reflecting throughout the program. It does not in any way reflect the availability of industrial waste heat, but it's just what we've got in the program. And we've supported quite a number of non-metallic minerals applicants, and followed by chemical and food, and then basic metals. Those were the typical sectors that we supported through IHRS, and quite a few more sectors as well lumped into other manufacturing sectors. Well, this was quite a surprise for us in the IHRS administration team. I mean, apart from us providing funding for the phase 1 and the phase 2 activities on feasibility study, preliminary engineering, and then implementing the project, we actually found quite a few applicants appreciating the process of IHRS, or the application process, because it was a comprehensive due diligence process for them. And going through that process, they actually they were able to negotiate better payment terms with their suppliers. They got some pretty useful alternative perspective from the review of their applications, and they got plenty of application support as well. So overall, quite a positive experience for the applicants, considering how resource constrained some of these sectors are in participating in public schemes. Now, yes, it's hard to fit all the lessons learned in the 10-minute context, and I've picked these 4 items, just to fit within the time frame. Any of this one point, I'll happily go on for hours on it. But just on the point of the first point on timing, really. So opportunity window is extremely transient, right? So if you look at a 30-year lifespan asset, your window of opportunity to act on it is boiled down to sometimes a year or 2 years if you are really good at planning for it. So it's the more you front load your planning on such critical projects is extremely critical, and then you throw in the complexity of changing business needs, market situations, economic conditions, and of course you throw in a pandemic as well. It just throws things out of line or out of plan, and we typically observe that many of those participants who invested their time, effort early in the game, in the process, usually come out with better decisions and better feasibility studies and better success, basically. So, I mean, the takeaway on timing is also on for industry is that a long-term strategy to address industrial energy efficiency or energy efficiency in general, or your resources is just critical, and for policy making is a framework to support for long-term support is just critical, because it's you can't really capture, everyone's got its own transient, its own stages, so it would be good to have a long-term program that supports industry throughout its lifespan. The second point I like to highlight is the importance of feasibility study. I just can't stress enough how valuable and how extremely critical feasibility study is, and how resource intensive it can be as well. So scoping of feasibility study is never enough. I mean, you will never be criticized for not doing enough. There are multiple competing resources for any resource that you're trying to work on, and of course it's some of this feasibility study will be depending on who's running it. You got to be conscious as an industry or a business owner on the biases within the feasibility study. Typically, you would get a technology provider to give you a feasibility study along with what you're buying, but it's hard to get an objective view to look at what are the competing opportunities or resources, and it takes quite a bit of effort to get a good perspective on it. We're also very surprised to get very interesting feasibility studies that even on waste heat recovery, which is very well established opportunity or technology, that they were looking at very intrusive retrofits, and as Mark mentioned earlier in his presentation, if that there are many complexities and there are many tangent points within the system that you can look at and digging onto it. Each of this tangent or each of this opportunity is a feasibility study on its own. So, and one other interesting point to raise is, apart from the technical elements and the commercial and the financial elements, I can't stress that enough on the health and safety points as well, because we did observe that some projects that had fantastic feasibility study scope, and they got hit with health and safety issue right at the end, and that just that just threw the financials out of proportion, and sadly project had to come to an end on that as well. So I'll skip on the point on heat networks, as is being covered quite extensively by quite a few presenters here, and I'll just touch on my final point on temperature matters. Yeah, Simon has given a very good overview of the challenges and how much support is needed on low grade waste heat. We IHRS, we're fortunate enough to be supporting quite a few applicants on this. I mean, not to mention how complex, how expensive it is, and each of this the commercial terms for this project usually goes on for 10, 15 years and involves multiple parties. So it's highly challenging. There's plenty of opportunities, but plenty of hurdles to in the mix as well. So just can't stress enough on how much support is needed on low grade temperature waste heat. So with that, I'll conclude on my slides, and happy to take questions. Thanks, Simon.
Thanks very much indeed, Yeen. So Tom, if we can pull Yeen's slides off, and if I can invite Dominic, Mark and Cliff to come and join me. I think, Yeen, you gave us a very helpful point to dialogue with BEIS about, which is the funding required to develop these projects in terms of the feasibility stage. We were chatting a bit in the speakers chat, hopefully you've all seen, just about what would be useful to talk about in this final wrap-up section, and Joel was keen to put each of you individually on the spot and ask you what either your biggest challenge you see as utilising waste heat in heat networks, or if you had a government official in front of you, what would be your one ask of them to solve that problem. So Dominic, as you went first, can I put you on the spot first and ask you either for the biggest challenge or the one ask to help make this work?
Well, they're related, as you might expect. Certainly from our experience, one of the biggest challenges is getting potential providers of waste heat to cooperate with us when we're doing feasibility work, or indeed project development work more generally. And I think, therefore, and I know it's something that's under consideration under the zoning policy that BEIS are working on, and that is an obligation to cooperate that would be imposed on heat suppliers, and then indeed that could stretch beyond the obligation to cooperate. That would be with the provision around the provision of data, but could go on also to mandate that that they supplied heat to a network. Okay. So those would be my asks.
No, I think that's really good. No, thanks very much indeed. Working down the list, Mark, do you have any sort of that one insight on the one barrier or the one ask of government, if you had to pick one or the other?
Well, from doing this for many years, it always appears to be a concept that's the right thing to do, but always funding is always the hurdle for mainly customers or concepts to be actually implied and actually put in. There does actually seem to be a shift at the moment in terms of people making the investment, mainly because of the net carbon neutral that people are aiming for. But it is mainly the funding and the incentives that I think clients and customers, food factories, other complexes or industrial applications that do need that incentive to get this investment in, because we're spending hours and hours rejecting tons and tons and kilowatts of rejected heat from some of the systems we put in that could be of use, which is quite exciting, really.
Yeah, no, absolutely. I think, yeah, that chimes very well with what Dominic said. It's about an obligation. It's also about the incentives to make it work. Cliff, any just brief thoughts? I'm conscious we're running behind time, but to give a chance.
I mean, yeah, people get excited with the heat recovery and projects, and I think doing as many cycles of optimization and energy efficiency first and continually before you kind of jump into your heat recovery projects.
Okay, that's brilliant. Thanks very much indeed. And Yeen, any final thoughts from yourself?
The one ask, to Simon, timing really. As in, if we can have some consistent, policy, incentive, support, to fit industrial needs, because it's again looking at the whole sector. Everyone has his own time frame, and it would be nice to get some form of consistent support so that they know where to go to when help is required.
Yeah, that's brilliant. So Joel, there you've got some clear takeaways for John. Consistent with support, which is incentives, and an obligation for people to make the waste heat available. So I think there's some clear instructions for the speakers there on what we're looking for, Joel.
Yeah, thank you for that. It's I could summarise that as both a carrot and a stick.
Yes. Yes.
And it's really interesting to hear that it wasn't just the carrot that's needed, particularly from the work that Yeen has done with the Industrial Heat Recovery Support Program. That the hurdles weren't always just the fact that you need money, but it's other elements like can you shut the plant down at the right time and other things like that.
Yeah,
So.
no, absolutely. That's brilliant. Thanks very much. I'm conscious we're very behind time, so if I can ask all the speakers to leave the stage, thank you very much indeed. Another virtual round of applause for everybody. We'll make that virtual round of applause work for the next conference, hopefully. So I'd like to invite Tim Ward onto the stage. Tim will be running through the government's next flagship support programme, Tim, so I won't big you up any further than that, and Tim is the Stakeholder Engagement Manager for this flagship support programme.
Good morning, or good afternoon, isn't it, of course, now. Thank you very much for the opportunity to speak today. I'm also very, very mindful that myself and Joel are the only ones standing between you and your lunches, and we'll run over time. So I'm going to give a quick overview of the Green Heat Network Fund and just give us a bit of its aims and how it could potentially help you with your projects for particularly capturing waste heat. Just as a bit of background, this summer I think it'll be 33 years in the heat network sector. I started sort of as a sort of point of reference and sort of this sort of as the Sheffield scheme was sort of starting to sort of really expand into its current guise. So I think that probably gives you a sort of bit of a timeline there. But right. So Green Heat Network Fund. It was. It's really its sole objective. It was just go back. It was announced by the Chancellor in the 2020 budget and last March, and its sole aim, really, its main aim, is to decarbonise the heat in heat networks, and that's both new and existing heat networks. So reduce the sort of carbon intensity, and as a sort of secondary sort of objective, also want to sort of help prepare the market, the heat network market, for future low carbon regulation, and ensure also compliance with sort of some of the existing regulations, such as the Future Home Standards that's on its way, and the heat network market framework. So it's really sort of preparing the way for sort of the low carbon future. It's a capital grant program, and it's, as I've already mentioned, it's both new and existing networks. So for expanding existing networks and decarbonising them, and also constructing new ones. We cover both the commercialisation and the sort of construction. So of course, the commercialisation can be of great use to sort of get schemes ready to sort of to be able to apply. So we recognise we need to support both of those aspects of a project. The scope will be England only, and it's open very much to the private and public sectors. So, timeline. I've already mentioned that we were announced last March, but we're following on from, as you see there in the graphic, we're following on from the great work that the HNIP, or Heat Network Investment Project, has done. So we're starting in April next year for applications. It's a 3-year program, and sort of so runs up to 2025. We started last summer a series of stakeholder workshops, for discussion forums, to sort of start to get sort of feel of the industry's thoughts on what we were proposing. That led into a call for evidence, which sort of took place last autumn, and then shortly after that, we launched a consultation process at the end of November, which ran through to January. So currently, we're sort of dotting the I's and crossing the T's on our consultation response, which is moving into sort of into approval. So hopefully, we'll be publicising or publishing our response to the call for evidence and consultation in sort of next month. So I would hope sort of certainly no later than the beginning of July, I would hope, but certainly we're aiming for June. And then the work really from now is helping develop a pipeline of healthy projects supporting the market and sort of getting a nice group of projects ready to sort of make early applications next April. But I'll lead on to sort of a bit more of the detail. We've taken a principled approach, really. It's all, as you'd expect, it's all about the carbon intensity. So we're not going to sort of say what you can and can't do to a degree, and let we're setting the sort of a carbon ceiling, a carbon intensity ceiling, and letting that really dictate what technologies, what fuels will win and what won't, because we sort of by virtue of the fact that we're setting this carbon intensity, certain technologies just will not meet the requirements. We have certain fuels and technologies that are likely to be excluded, and there's lots of mention already been in today's sessions, talking about CHP, natural gas fuel CHP, and yes, that won't be permitted in terms of the sort of primary energy, but there's still opportunities for gas CHP and also natural gas fuel boilers to sort of take a supporting role. So depending on how a project's sort of designed and conceived, there may be opportunities there. But again, a lot of the detail of this will be revealed in the consultation response. We're supporting sort of the plant for low and zero carbon plant, and also accessing the heat, so which is particularly important, as we've been hearing in the presentations today, accessing waste heat. So putting in the sort of infrastructure to sort of capture it, and then also any backup generation in the case of the waste heat recovery project, and then of course the heat network distribution system. So really sort of end to end. One of the points that we raised in the consultation is the sort of having a minimum. So to sort of try and one of the reasons for this is that obviously we don't want to be swamped with lots of tiny little projects. So we've had to set a sort of a level of entry level, and that's a 2 gigawatt hour per year entry criteria. So it's got to be more than that. We have had a lot of feedback on that, and it's likely, particularly for rural projects, rural locations where the heat density is a lot lower, that we're going to sort of take a view on number of dwellings rather than the sort of a firm and fast 2 gigawatt hour limit, or minimum, should I say. So that's one of the changes that's likely to be coming up, which again you'll see more when it's formally published. The application for and the way that they're assessed, it's as with HNIP, it's going to be quarterly application rounds over the 3 years that we run. We've also taken on a lot of feedback, and we want to make it as open and transparent as possible in terms of the way that we sort of scoring these, and we will be making available well before, in fact in July, the sort of application forms. There's a model, a financial model, a commercial model. There's going to be lots of guidance and support documentation, which enables a sort of 3-stage approach. The applicants themselves will be able to, in the sort of first stage, be able to determine themselves whether their project sort of passes muster in terms of 4 initial gates. So it's pass or fail, very, very clear, and the sort of documentation and the model will actually sort of indicate whether this is the case. So we've got the carbon gate, and that is based on a sort of a maximum ceiling of carbon intensity that we'd accept. We have a measure of consumer detriment, which measures, particularly in the case of domestic consumers and micro businesses, it will measure their whether they're going to be there's any detriment to them, and it measures against relevant counterfactuals. And then there's the 2 gigawatt hour per year minimum demand, which we mentioned. Again, that's likely to be different for rural projects, and also where a project's sort of traditional financial return is not as great. We want to give opportunities for projects that have got a really good social IRR to sort of to help. So that's another one where we've got sort of obviously clear benefits for the environment and the sort of clean air. So that's the first gate. So that's very much done by the applicants themselves. The next phase is where the sort of GHNF or Green Heat Network assessors sort of take over. The second stage is all about deliverability. You know, if we were to support this project, is it likely to sort of proceed successfully within the sort of reasonable timescales? You know, is the supply chain in place? Has it been tendered, for example? Are the contracts in place with anchor heat loads? In the case of waste heat, you know, is there a contract is it in place, or sort of certain sort of how well progressed are sort of heat supply agreements? You know, is the program there? Is the technical overview of the scheme? Is the design in accordance with the code of practice? Finance, is the balance of the funds in place? You know, and it's just really making sure that a project can actually sort of proceed successfully. So once you've passed that, we then move on to the sort of final stage, and that brings in an element of competition. And we have to have the competition element in there because, you know, we need to make sure that we're using the taxpayers' money sort of the very best outcome in terms of the decarbonisation. So, you know, we sort of, there's various factors, and these are likely to expand and adjust in the sort of final scheme when we sort of reveal the response to the consultation. But it's all about coming down to a figure of how many kilowatt hours delivered per pound of grant, and that's where there's going to be sort of an element of competition. But we will be putting a lot of support and guidance out there, and I'll come on to some events and things that we're looking to host in the coming months. So the next step I mentioned, we'll be publishing the consultation response, but we've got the guidance and application forms. But I'd say we've got a plan to have a lot of ongoing workshops, sort of some of them more general, and some of them sort of focusing on certain aspects, you know, commercial, financial, negotiating heat, for example, could be one of them. We'd probably do some further events looking at utilising waste heat. We may well be doing something potentially, say, with the Coal Authority and looking at utilising waste heat in flooded mine workings, for example. And these are all sort of events that we're looking to do, and they'll all be. We want to sort of publicise them as much as possible and get as many people in there. We want to really help get as many good projects ready. Dare I say, shovel ready to sort of make applications next April. So as soon as we go live. So I said I'd keep it really brief. I hope I haven't run over too much at all. If you want to be added to our mailing list, please email us. I'm going to post in the chat the sort of that email, so you can just cut and paste. But it'd be great to hear from you. Let me know by emailing that. I'll add you to our mailing database, and we'll be in touch as soon as we've got announcements, events to sort of publicise, sort of significant information to sort of help you. So yeah, that'd be great, and thank you very much.
Okay, thanks very much indeed, Tim. Conscious of time, although there's already one question in the chat, which we'll most probably bring you back to answer. So we'll let you go off the stage, bring Joel back on, and if we can upload the final presentation. So this is really about other sources of funding for Joel, just to wrap up the event. And conscious of time, I'm afraid, Joel, as you are as well, I'm afraid.
Yeah, so thanks for that, and once again, just thanking everyone for being on here and providing some really good insight. and I'll try and keep this brief, though it's pretty useful and important to just know what other funding's available. So the first thing that I should really plug is my own team, the Heat Network Delivery Unit, HNDU. Our objective really is to support the delivery of low carbon heat networks at pace. Typically, we provide grant funding and guidance. It's usually directly to local authorities in England and Wales, but we can also do some direct funding. But either way, if you have a heat network, or you've got a proposal, or you've got a waste heat source, and you want to find out whether there's some people nearby that can make use of it, we're a good port of call. We've done lots of studies, funded lots of studies all across England and Wales, and have got pretty extensive contacts throughout the sector. So just really remember that we're there. The current figures that we've got on the government website are that we've awarded 23 million in total, although it's probably more than that now. And we've done over 250 unique projects and supported over 150 local authorities. More information can be found there. Yeah, just get in touch if there's a heat network project that needs some looking into. It was briefly mentioned, so the Heat Network Investment Project, HNIP. There's not a lot of time left on this, so the last applications are October this year. It was a £320 million grant and loan scheme to help deliver or expand new networks or expand existing ones. And the objective was that £320 million would leverage over £1 billion of investment because there'd be match funding. As I said, it finishes in October. It's managed by Triple Point. It's going to be superseded and improved by the Green Heat Network Fund. So other things to be aware of. So this thing called Beehive, which is the BEIS Heat Network Investment Vehicle. It's a dynamic purchasing system. It's for public sector bodies. So that includes central government departments, arm's length bodies, executive agencies, non-departmental bodies, devolved administrations, local authorities, things like the NHS and charities and universities and what have you, schools and colleges. And it's really just to try and help coordinate a bit better the investment into the sector. Other sources of funding, so it's probably more pertinent to what we've been describing today. There's the Industrial Energy Transformation Fund, the IETF, which took on the waste heat element that was previously delivered independently by the Industrial Heat Recovery Support Programme, the IHRS, which Yeen spoke about. And why I put this here is that this can essentially fund the works to support the heat recovery within an industrial application. And then you can use the Heat Network Fund to fund the actual heat network grabbing that heat. The main thing with these is that you need to be aware that we're not allowed to double fund. So you can't get the heat recovery to be paid for by both the IETF and then also by the likes of the Green Heat Network Fund. This is quite standard practice. We were able to deal with this with the likes of RHI and HNIP, the Heat Network Investment Project. You just need to make sure you're not double funding. We can provide more details about that after this if you want to know more. And that's a £315 million fund. And it's, as I said, it's supporting the overall energy transformation, but waste heat's part of it. There was the public sector decarbonisation scheme, although it's closed, it has been used to fund heat networks across public bodies. I was involved in one in particular, which is sort of building a network across a hospital, which is really exciting with boreholes. So that's something to be on the lookout for. There's also new funding. So this was briefly mentioned by John at the beginning. We're still in the design stage, but this is the Heat Network Efficiency Scheme. Similar to what Cliff Bradshaw from Cotopaxi was describing as the process that you sort of need to undergo in an industrial setting. This is the first step. Try and make your network more efficient, try and utilize the energy effectively, essentially improve efficiency, lower the temperatures, and then you can prepare it for that big investment in your low carbon or net zero ready technology. And the idea is that this scheme would feed into the likes of the Green Heat Network Fund, so you could use this to prepare your network and then the Green Heat Network Fund later. But watch this space on that programme. because there should be more information to come as we work out exactly what it's going to look like. And I should also say it's a capital is planned to be both what we call capital and resource, so you can use it to fund research, but you can also use it. It will also be used to fund some of the capital works. Other things to be aware of. So you heard a little bit. I'll talk about that a bit later. So there's some work we've done, which is the City Deep, which is the framework we use decarbonisation project. It assessed 5 major cities and looked at a heat decarbonisation process for them and where heat networks work. And the main things to come out of that's really interesting. Well, loads of it was really interesting, but for us is a standardized tool for heat network zoning, and to really kind of look at the hierarchical method of looking at heat decarbonisation. So we're not just flogging heat networks, but we're looking at it as a whole system approach and looking at whole system benefits. And other interesting projects, apologies for this coming across quite small and whizzing through it. You've heard about Green Skies. There's also LotNet, and so Green Skies is there to investigate and deliver a detailed design for a smart energy system that integrates low carbon technologies across heat, power, and mobility. And LotNet it stands for Low Temperature Heat Recovery and Distribution Networks, and that was to demonstrate and prove that low cost, low carbon thermal energy networks integrated with electricity and utilities networks can form these flexible and highly efficient smart grids. Lots of partners, I'm involved in both of them as well, and both are really good projects which the information and findings from will feed into our thinking within government. So other support for the sector that we dealt with, so there's been managed over this time. So this was really shown up over COVID, and I really would have liked to have had a bit more time to talk about this, but we realised that there was some very specific issues that the heat network sector would face as a result of COVID. For example, if a heat network operator went bust and they turned the heat off, that could be a lot of people without heat, or businesses, and some of those could be critical, or the individuals could be vulnerable. So there's a voluntary group of companies across the sector who have come together to form what we call the emergency responders. That is a paid for technical service to essentially help keep networks operational. The telephone number's there. It's worth sort of shouting about that while it's still active. The Heat Network Exchange. So this we created a website that basically hosts any organisation involved in the sector, from an electrical contractor to a lawyer. There's also an ask notice board, and we created that at the time of the pandemic, but actually it's pretty useful moving forward. We don't know what other supply chain challenges may come. So that ask notice board could be used for anything. For example, you've got an old network that's got a really weird pump that's fallen over. It's going to take you 3 months to get a new one. Put your post in there. And we also produce some guidance as well for managing networks during COVID, but it's also just some good practice. Some of it's quite simple stuff, and some of it gets into the more nitty-gritty. So all of those links are there. And within the guide, it's also got the phone number for the emergency responders, which then leaves me to just say thank you, as Simon's turned up to try and kick me off the stage. So a big thank you to both the UKDEA, BEIS, and all the speakers as well. Sorry, yeah, Simon?
I said, stay on, Joel, stay on, please. Tim Ward, can I please just invite you back onto the stage, please, Tim? Because there are a couple of questions there, Tim, which you've now had a chance to read. I think one is slightly easy and one is slightly more contentious. Do you feel able to respond to those, Tim, please?
Yeah. I will say, I would love to say just wait till next month, but in terms of, I'll answer now. I've got 2 questions there. Have I? One from Connell and one from Dominic.
Yes.
I'll start with Dominic. What counterfactual? I presumed you mean counterfactual for the, well, there's going to be multiple counterfactuals depending on which type of, whether it's a new scheme or but again, we consulted on having a sort of carbon intensity of using a seasonal or SCOP for of 2.5 against a grid intensity figure. That's likely to, likely to change, and it's going to be based on a gram per a value of grams per gram CO2 equivalent per kilowatt hour. I can't give you the actual figure. That's going to be revealed next month, and it's not because I don't want to, but I can't. To answer Connell's question, the completion, on the competition stage, I'm not aware of anything in terms of a minimum carbon saving per pound grant. It's going to be more of a case of, that calculation is the way of ranking them in terms of their competitiveness. So what there will be, and I didn't mention, is there is going to be a cap. And there's let me just read this: a pence per kilowatt hour of grant as a cap on the grant, and there's also going to be a percentage cap on the capex. The capital grant. So there's going to be there's two sort of elements that will be brought in.
So, sorry, Tim, just because I'm sure many others in the audience will be curious about that. When you say a cap on the grant, do you mean a cap as a percentage of
the capital cost of the project? Yeah.
And could you share with us what that might be?
I'm sadly no.
I'm assuming it's quite the
but yeah. So say it's obviously we want projects to sort of succeed. So we want to sort of get them out there. So.
Just one thing you hopefully definitely can tell us, the answers to these questions have been asked. So just to be quite clear, when do you expect us to be made aware of the answers to these questions? Because you're responding to a consultation response, aren't you, I think?
Yeah. I mean, it's the document, and I say the document is, I think if it isn't already, it will be going around. It has to do what's called a write round. So it's going to go around everybody, make sure the government departments are all happy and it gets signed off. So as soon as that's happened, we're hoping that it's going to be June. June. When I say potentially July, it would be early July because we've got other things happening, which we need to publish the guidance and the documentation and the application forms. So we need to be very, as soon as possible, because there's a lot of other things hinging on that. Us going out there and helping sort of inform the marketplace and the stakeholders as to how they need to use these and build up some momentum before April. So it's
I mean, I think on behalf of all the members of the association, we're keen to be able to make applications the second April starts. Really, not wait around for another year for it to go live. So we want a sort of a very, very full pipeline of projects to sort of feed into the machine in April. Yeah. Okay, lovely. Thanks very much. Okay, Tim, I'll ask you to leave the stage.
Thank you.
Closing remarks from me. I'm conscious people are heading off towards lunch, but just echoing Joel's point, a really big thank you to everybody who came along and took the time this morning. We've been online now for 3 hours and 22 minutes, and a good proportion of you have stuck with us. We had over 200 registrations for this event, and it will be on the UKDEA YouTube channel. So, and I think what's been interesting for me is two things. One is we've had a really good conversation about the whole thing of wet waste heat, and it's also raised a number of things that I'm really keen to take away and discuss with Joel moving forward about other things that we need to be considering in this sector and way forward. So I suppose before Tom closes it, Joel, any final thoughts?
Just another big thank you, and really it's been fascinating to hear both the scale of the opportunity and challenge that we have, and I hope that the number of people that have come today show that we're not shying away from that challenge, and we want to face it head on and do what we can to drive us to a sort of sustainable net zero future.
Brilliant. Thanks very much. Okay, we'll call it a wrap there. Tom, if you close the event, and we hopefully will see you all at the next event in a few months' time. Thanks very much indeed.